I was going to say, who's the DJ, but you didn't have to mic me to do that. Someone asked who's picking the music. In a good way, I think. And I assumed it was you. Okay. Well, I guess we're starting. All right. Take your time. It's fine. We got all kinds of time.
I'll do it on stage.
Yeah, it's fine. So Jeff will be texting. It's good. It's chill. The cold brew is working again, by the way. So the very important announcement. So that's handled. But here we are, back day two. Second day of DevOps Days Chicago. I was gonna be like, why aren't you advancing the slides, Kevin? But it's because I have the clicker. So, haha. So hey, welcome back to DevOps Days Chicago. Hope everybody had a good time last night. Well, first of all, I hope you had a good time during the day. I presume a bunch of people had a good time last night. I heard. So if you weren't here yesterday or you had too good of a time, you don't remember anything from yesterday, I'm one of your MCs. I'm Maddie.
And I'm still Jeff. and we're going to walk you through the next, 7 hours or so and, wrap things up. So before we get started, I want to hear how many people enjoyed the open spaces. You know how much I love those, so I just want to make sure. All right, good, awesome. Good. Yeah. I know we had a lot of first-time attendees, so I want to make sure you guys felt the love. Like we said yesterday, you'll be seeing a lot of us, but again, this is put on by a host of people. You see our organizing team on the board there, so give them a round of applause for just doing an amazing job with this conference.
And, so if you need anything throughout the rest of the day, you have any questions, you can find any of these folks or other volunteers. We're all identifiable by our red shirts. And again, I will make the joke again. I'm sorry if you're wearing a red shirt and people are going to ask you questions, but,
I wore the red shirt today.
Now, to be fair, if you read the emails I sent, it would have said that the organizers are wearing red shirts, and so you could have coordinated your wardrobe appropriately. All right, it's good. So Wi-Fi, the network is convened, password is stay connected, shared resource for a whole lot of people, so don't get crabby if it slows down, and try not to, stream, whatever, something big.
The bear.
Yeah. No, you can do that. That's cool.
We got live transcriptions available again today. Thanks to our sponsors for that with SIM. Live transcriptions will be on the monitors. You can also download it to your personal device.
Yep. And, you can find us. Our Twitter handle is DevOps Days Chi. We're on LinkedIn, on whatever social media platform has hashtags. Hashtag of DevOps Days, because we think about DevOps Days globally. But please, take pictures, share things you learned. We saw a whole bunch of great posts yesterday of the different things people were learning, and awesome pictures. And so if you hear any words of wisdom, any insightful things or sufficiently sophisticated trolling, please, share those out.
Great way to connect with your fellow attendees as well, as you sort of just watch the hashtag and see people post and say, oh, that's right, I was with them in an open space. Great way to reach out. So day 2 is going to follow very similar to day 1. In the morning, we'll have our full talks. We'll have a break for lunch, followed by Ignites. You don't want to miss the Ignites. We saw the lineup, and it looks absolutely amazing. So I'm really excited for that. For those that missed yesterday, Ignite is a 5-minute talk format. Sounds easy, incredibly difficult. 20 slides, auto-advancing every 15 seconds?
20 slides every 15 seconds, auto-advancing. You do not have control.
No control, so it's a really good time. After the Ignites, we'll have 2 options. You can either continue
before that.
Before that.
We will be doing the raffles and giveaways up here on stage. So many sponsors at their booths have been, you can enter for raffles, all that fun stuff. We have some time at 1:30 for those giveaways, but also this is the time that if you have filled out your sponsor passport and entered for that, and we'll remind you about that in a second, that's also when we're going to do those raffles. So now after that,
we'll have 2 tracks. You can do either the workshops that'll be in here again, or we'll go through the open space process again, which, like I said, is amazing and fun, and looking forward to that.
It is, well. and the spirit of fast feedback, and by fast feedback I mean we've probably been asked about this for the last 8 years, and we did it now but somebody mentioned it and remember it. So as you may recall, if you were here yesterday, you come up, you propose and everything, and that's not necessarily the way everybody wants to do that, so we're adding a capability to do it through a Google form. We'll work that way, so if everything's covered. But Actually, just real quick before we go into that, we talked about people doing the open spaces. Someone asked me when we come up here and said, hey, you know, how many open spaces from yesterday are spilling over today? And I said, well, I guess we'll find out. But just anybody in the open spaces yesterday that feels like we're like, yeah, that conversation was not over. So, or everything was done. Okay, well, at least one person think there's still more to talk about today. That's good because we got a lot of time. So, cool.
Here's our today's speakers. Again, an amazing lineup. Really looking forward to it. First talk is right up my alley, so I'm looking forward to that with Dean and Craig.
And again, if today is your first day here or you don't remember, you missed the opening remarks, if you take a look at your badge, you'll see that it says participant. Everybody's badge says participant. I especially did enjoy, so they are... There's some of them are different colors, so while they might not say sponsor or speaker or organizer, we might have done a little thing. And one of our speakers, Just Care, posted on social yesterday and said, "Oh, it's like different, skies. So like this is like twilight, this is dusk, this is it's on fire, And I was like, didn't really think about that, but also it's 2023, so maybe right."
And don't forget, there's also a map on the other side of your badge. So if you weren't here yesterday, just remember you can flip your badge over
and then
and get a map of the conference.
Speaking of that, and I think we got the map coming in a minute. So not speaking of that, just a reminder again, code of conduct is very important here at DevOps Days. It is on the website, and we want to make sure that we follow that. And again, if you can see that at DevOpsDays.org/Chicago/conduct. If you have any issues or need to report an incident or a violation, please you can either email to help@DevOpsDaysChi.org or find one of us in a red shirt. You may have received a link in the last few days for a code of conduct software called Call of Conduct. We are not using that. We will maybe try that again in the future, but we're constantly evolving. So.
Okay, again, health and safety reminder, masks are optional. No harassing people that made a different choice from you. So feel absolutely free and comfortable to wear your mask if that's your preference. If not, that's perfectly okay. If you start to feel sick in any way, just kind of let us know. I don't think we're doing thorough contact tracing, but it's good for us to be aware. So if you do end up testing positive or anything like that, just let us know at Chicago@DevOpsDays.org. In addition to that, there are a bunch of free COVID tests that we have left over at the front of the conference center. So if you want, they'll be by the stairs.
Yeah, I think after now that everybody's kind of in, we're just going to kind of put them there. Take what you want, So please take what you want, because I'm going to take a bunch, but while my basement is.
I got kids. I got to take a ton.
Yeah.
School's starting.
And again, if you need anything, you can always email us. Go to the registration desk, and
again, thank you to our sponsors. None of this is possible without the help of our sponsors. So if we could give them a round of love. And, make sure you visit them in the 2 food areas. Like I said, there's a ton of great services, products out there. I'm sure that they are going to be able to address some of your needs in the organization.
I'm trying to remember if there's in the day 2 slides, if there's the map or not. There's not. Okay, so I'll talk. I was at a thing about the location. We'll talk about. Okay, cool. So last night or early this morning, you will have received an email that was kind of our updates for today, but there was a link in there for a feedback survey from yesterday. If you didn't get the email, you didn't find it or whatever, that's that QR code right now. So if you want to grab that, we have a survey for your feedback from yesterday. You can grab the QR now and load it up. You don't have to fill the survey out right now. And we'll be sending another one after today. We'd love to get your feedback, your thoughts, ways we can continue to improve, or where we don't need to improve. So you can feel free to also put all sorts of glowing things about how much you love our stuffed yaks and things like that.
Makes us feel good.
So before we go in, we don't have a map slide in here, so I wanted to just, this is a big venue, everybody get lots of steps in yesterday. Everybody have your device going, wow, you're walking a lot. But the pro tip, if you haven't figured it out, is it is a big circle. So if you're not quite sure where to go, just start walking, and you will eventually get there as long as you keep walking in the same direction. But hopefully we kind of puzzled that out. But with no further ado, let's get started with our first 2 speakers of the day. Joining us from Discover are Craig Katz and Dean Park.
All right. Good morning, everybody.
Good morning.
So I'm Craig Katz. I'm the Director of Infrastructure at Discover. Been with the company about 4 years and currently in charge of building out the cloud infrastructure and managing it for teams to make the journey.
And I'm Dean Park. I've been with Discover for 24 years. Spent most of my time as a front-end application engineer, did a lot with APIs, moved into architecture, and now I've been a leader in application development, and had the privilege of working the last couple years in infrastructure, leading the CI/CD and observability spaces. All right, so we're going to talk today about Discover's transformation, really using CI/CD and the cloud platforms. So let's jump back about a decade. Right, Agile is starting to grow at Discover, mainly adopting in our public-facing applications, right, our account center, our applying for card flows. We're getting the right teams put together. We're getting the right roles defined. A lot of transformation taking place, but we're still using an older technology stack. Right? We hadn't really gone into what it takes to make those teams empowered from a technology standpoint. We still had a lot of centralized processes. So for example, if you wanted to do a build of your application, you would have to submit a request, a centralized build team would work that queue, build your application for you. Now granted, they didn't really know your application, but they were building it. So if anything failed, they would just let you know, hey, this thing broke. It's on you, figure it out, but you don't really know what they did. So it was nice that it was kind of decoupled from the application teams, but it was problematic because teams didn't understand what was really happening. It was kind of a throw it over the wall approach. And we did a lot of analysis early on all these different processes and why it was taking so long to get code into production. And in the customer-facing space, we found out that on average, it was about 12 weeks to go from ideation all the way to get your code into production. And when you did that, everybody was on a call all night long. It was terrible. I'm sure some of you have lived that life. And so we had to do something. So if we jump ahead a little bit to 2016, we started to make some good movements on the technology side. We brought in Cloud Foundry-based platforms, which brought some goodness, right? We had a lot of problems with scaling our infrastructure in the past. With the Cloud Foundry, it's virtualized underneath the covers. If teams needed to add more instances, there was no provisioning hardware, which you didn't know how many months that was going to take. You would just tell it how many instances you needed, and you could even tell it to auto-scale, which worked okay. Routing was also built into the platform, at least for the final mile. So once you got your calls to the front edge, you could do some pretty cool stuff, right? You could manage that route and go between different instances. You could do some blue-green deployments. And so engineers really started taking advantage of these capabilities, especially since a lot of this was exposed as APIs, right? So we kind of went full circle where we took the engineers for a while away from being able to control things. And this was our entry point back in there. Here's an API. Here's how you secure your calls. You now have the ability to manage your platform. And also, some of the services started making an appearance. So we brought in AWS as our database platform to use. And that brought a lot of goodness, right? We no longer had another handoff with a DBA. Also, CI/CD tooling came in. So we used GitHub, Jenkins, SonarQube, all kinds of different things, and really turned all that over to the engineers to start utilizing. So our tech stack got better. Okay, so we've got modern platforms for the most part. We've got our existing engineering practices, because we haven't really retrained anybody or done anything with that. So how's this going to go? Well, some good, some bad, but let's talk about the good first. The API-enabled infrastructure was a huge win. Like I said, it brought people full circle. We used to be able to go down to the servers and do our work. That got taken away from us. This gave us the ability to do it in a controlled manner and a secure manner. Jenkins, some engineering wins with Jenkins, right? A lot of experimentation. We also found out that you kind of open up the floodgates to some of these tools and you get some bad practices. Some things were being done that really could have been done in a better technology choice. But the fact that we were experimenting and learning is a great thing. Also worked, the teams were learning about 12-factor applications, what it takes to move their application from these legacy platforms into the cloud, and it's starting to catch on. And like I said, teams were even using those cloud data stores, and one of the big challenges there was just the new role that brought to the engineering teams, right? They're used to working with DBAs, and having the subject matter experts that can really help them with their queries, help them with their usage of databases, that's now on them. And that was a big learning curve. All right, so let's talk a little bit about pipelines. So having this autonomy of all these tools being there and teams could go in there and build their own pipelines led to the great experimentation, but it also led to a lot of different opinionated pipelines for those product teams that did really good things for their products, but it didn't really take into account the greater capabilities that Discover need as a whole. So we're talking about compliance aspects, security, audit, and change management as well. So there was some local reuse, which was cool, and we were starting to kind of build what could be a great thing as far as pipelines goes, but it was sprawled, complete sprawl across the organization. So had to take a time out and really centralize our thoughts on what Discover needs from an enterprise pipeline capability. So we formed a program that we called Trident. So Trident brought in those compliance, security, change management aspects to the pipeline and allowed engineers to still have their opinionated view of what they wanted it to do for their product. We established principles of Trident and really brought in the right key players of the organization to contribute to that. We started defining what those core capabilities needed to be, what the roadmaps are going to be to get there, and then we eventually stood up a small enterprise team to start working on this. But we quickly realized that one small enterprise team is not going to be able to support hundreds of product teams, nor did they really know everything those product teams wanted to build. So, Craig?
So with the stand-up of Trident, initially they also set up an inner sourcing community, which was key, because when you inner source across your enterprise, not only do you obviously increase your engineering capacity for building and delivering, but it also gives you higher rates of customer satisfaction because the engineers that are contributing to the pipeline, definitely understand their product. With everything that we talk about with software development and delivery, it's all about feedback cycles. Do something, measure it, act on the feedback, do it again. With having engineer contribution, you can really shorten those feedback loops, which is key. And then, as I told several engineers who were involved with it, is you get that mix of both selfishness and altruism. So you get the product or the feature or the capability that you need, which can benefit many people, but you also get to implement it in the way that you prefer. So if you get in first, you can get both sides of the equation. As we were going through the Trident delivery and building it out, we also found that we were going to run into challenges. Being in a large enterprise like Discover, there are certain things that might impede your progress from time to time, be it corporate roadmaps or tooling selection. So Dean and I are here to tell you, there were bumps along the road. This isn't just we had a PowerPoint, we got through it all, boom, today everything's perfect. Along the way, there were some decisions that were made, like here's how we want to architect our pipeline. Okay, we need to bring in this tooling. Oh, from an enterprise contracting level or competing products out there, we're not going to bring that in. Okay, so we'll have to refactor. Other times we did bring in products to supplement portions of the pipeline that didn't necessarily work out. Again, and you're going to hear me say this a billion times, feedback cycles. It's not that you're not going to make mistakes. The question is how quickly can you make them and how quickly can you react to them? And so those are some of the learnings along the way with the Trident project and the inner source community. But what did happen over time is that we built more and more features and capabilities into the product. And when you have more capabilities in there, then more people will adopt it. And when you get more people that adopt it, you get more people who are encouraged to join the inner source community to flesh out the portfolio they need from an enterprise CI/CD pipeline. So some of the things that we had to add was different features, capabilities, language support. So a couple of highlights that really resonated with both the developer community and the product ownership community was a release fitness report. So a way for somebody to see within a given release, what were the stories involved? What were the commits involved? What were the change tickets created? on a single pane of glass with the capability of being able to trigger or release from that point of view. We started with doing Java because, well, you know, Java's pretty fundamental. But we needed to add UI support, so we brought in React. We have a lot of Python development at Discover, more for data analytic type stuff, but adding Python support to the pipeline. The pipeline included all sorts of quality measures, like static code analysis of both the quality, like code cleanliness, variety, you know, code duplication, vulnerabilities and how you're structuring your methods, blah, 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 as well as security scanning for open source libraries that might contain vulnerabilities. With the need of a pipeline to have fast feedback, we introduced parallel deployments. So you can put your code to multiple areas at the same time, run all your test suites simultaneously to shorten the window before you know if you're good or if you're not. We added canary release configuration, so you could have your code out in production and be able to just allocate a small sliver of traffic so you could get the feedback of whether things were performing and then be able to scale up or scale down, as well as kind of optimizing the way the pipeline worked to promote things like performance testing, integration testing, contract testing. These are things where we had kind of dedicated images inside the Discover environment. So basically you could just say performance test, go here, go, instead of all the infrastructure setup, abstracting that away for the engineers. But the really crown jewel of the feature that we added was change management. We automated change tickets, preferring a blue-green approach for deploying and releasing into production, which meant as soon as your code passed all your tests and you felt confident that your code was release ready, you could have a ticket created and proceed, which number one, kept the uninterrupted flow, and number two, it gets rid of all like the annoying busy work of putting together a change ticket and having to go through CAB reviews and typos and sendbacks and all that stuff. So dramatically increased the productivity of people who use the pipeline, as well as the satisfaction of people using it, and it really increased the adoption rate.
All right, so we're going to jump ahead again. So now we're in 2022. Kubernetes has been at Discover for a while. It's been evaluated, kicked around. Now we're kind of getting ready for open for business. So we're at a kind of a turning point where what are we going to do with the entryway into Kubernetes? So with Cloud Foundry, it was a little bit of an open door, right? Here's the API to Cloud Foundry. Here's the tooling for CI/CD. Go ahead, do your thing. And that's how we got into that bad spot of all those various pipelines. So we made a decision with Kubernetes to have one single way to get there, which was going to be our Trident 2.0 version. Now, Trident 1.0 had been around for a while, or 1.x, and had been used with PCF or Cloud Foundry and some other environments we had. And we got a lot of good learnings from our engineering community. A lot of feedback. The negative feedback you hear quite loudly, and that really helps, though, right? I mean, people are passionate about this stuff. So we took all that feedback, brought that into Trident 2, made it more engineering friendly, and tried to make it the single point to Kubernetes. We had really good support from our executive leadership all the way up to the CIO to have the enterprise adopt one of the Trident pipelines, one of the approved pipelines by the end of 2022. So just for the sake of scale, I mean, we're talking over 1,000 different components that are going to production. That was the ask of application development at Discover. So we established end-of-year adoption goals, and we had to be very good at how we're going to help those teams achieve that. We had like I said, we had a very small core centralized CI/CD group composed of one area that was there to support them. The number of tickets and support questions we were getting when we started this enterprise adoption really kind of massively overscaled what we were expecting, because all these different customized pipelines at Discover were trying to figure out how to adopt this new Trident 2.0. So we had to kind of take a different approach. We established your communities, we established office hours and things like that, but the sheer scale of this just it wasn't working. So we decided to take another approach. So luckily, Discover has a Discover Tech Academy already established inside of Discover, and it's really our centralized engineering hub. So engineers already knew about our DTA site. They go there, they find different blogs, they find engineering experiences and how-tos. So it was the obvious place for us to put our Trident onboarding documentation. So we already had platform docs, written by the team, like they're more of an SDK, right? Like here's kind of what Trident does, here's the various parameters, things like that. But when you ask 1,000 components to adopt it, that's not good enough. We learned that very quickly. So what we did was we brought in a small engineering team to really focus on this site and do it from an engineering persona. So these were real engineers that were also tech authors. So they adopted Trident. They used it, they documented it, based upon what the scenario was, and then brought that back to our power players inside the organization to try out and provide feedback. So as Craig said, we just kept iterating on it and kept getting feedback from our community. And it was really critical to how we scaled the organization. And if you, hopefully, some of you saw Jeremy's talk yesterday on the Legos and how important good documentation is, right? This is why we did this, right? We took the time, we spent the money, we got good people to build this out. It was really kind of a turning point for us being able to scale I think we adopted over 900 applications in 2022.
So Trident was defined as the way to get there, but the whole point, and as I believe the title of the presentation, is Discover's Journey to the Cloud. So I want to talk about the combination of cloud hosting, CI/CD pipelines, and Kubernetes, which are kind of the components that Discover put together. And those things do encompass all the ilities. So AWS, or a cloud hosting provider, has hosting cloud infrastructure as a core capability. Discover has some great data centers. We've been supporting and managing them for a while. But when you work with a cloud provider, you get service on demand, you get constant feature development, and you've got a company that is based on the fact of how to deliver that particular product to people. So having a data center isn't a differentiator for Discover, but it's a core competency for cloud hosting, and so that's kind of where we settled on that direction. If you are using Kubernetes, it's a hosting platform that unlocks resiliency, recoverability, configurability for your applications. So that way you can launch what you want and be able to scale up and scale down. It does maintain a higher level of security profile and the concept of portability. And then bringing that together with Trident, it's a pipeline that emphasizes testability while encouraging and enhancing deployability and releasability for customers, or for applications, so that way Discover's customers can, again, get the benefits of those frequent feedback loops. So a lot of people have, and there's been a lot of stuff on the internet lately about like, okay, first it was moved to the cloud, now it's like, oh, let's move away from the cloud. So there's a little personal bias here, is cloud hosting is a commodity, as I was kind of describing earlier, whereas Trident is something that we needed to build in the context of Discover. So it's like that build versus buy, build our pipeline to encourage all the things specific to Discover from a security, compliance, especially in a highly regulated industry that Discover is in. It made sense. Cloud hosting, I think, is good because they're continuing to develop and evolve their product in ways that, a financial company, it isn't in their core suites. But the combination of those three things, cloud hosting, Kubernetes, Trident, it offers the resiliency, the quality, the security that hadn't existed at Discover until this point. And the flexibility of that combined platform eventually will allow for cost optimization, as well as just the other inherent factors of that strength of platform. So what we also had to encounter at this phase in our cloud migration is the concept of lift versus shift versus building cloud native. And this is something that people have also debated a lot on the internet. And in a perfect world, I'm totally on board with building stuff cloud native, doing it right, doing it the first time. But our world is typically not perfect, slightly less than perfect. So the lift and shift approach, I believe, makes sense. When you migrate stuff into a Trident pipeline that's analyzing levels of quality that you haven't been measuring before and getting fast feedback loops on it, it gives opportunities for engineers to take that iterative feedback and make it better in learning it. And it's on the flip side, if you say, I want to build cloud native and do it right the first time, first of all, nobody gets it right the first time. Like, we all make mistakes. We're collectively human, mostly human, et cetera. But if your engineers haven't been building native cloud applications, are they going to have the skill set to do it at that point? Or if you bring in like expert contractors to help with that, are they going to be around later to help support, or will they be taking shortcuts that aren't discovered till later? So the approach we took at Discover was lift and shift. And again, some of my biased opinions about why that's going to work is to, again, iterative learnings. This is kind of the overall view of how we worked at Discover to do the migration. So starting with the gray items at the top, there's some onboarding to do to the Kubernetes platform and onto Trident. And then you get into the blue phase. Is your code testable? Do you have test suites written that'll give you the quality that you need to feel confident that your code is release ready? Do you have performance testing? Do you have static code analysis? Can you do unit testing? Does your code need to be broken up in ways to make that testing possible? For applications that weren't originally built as cloud native or for automated testing, it's okay. This is something that we all need to learn and incorporate over time. After you completed that via Trident, you had the option of deploying to our legacy platform or our cloud hosting platform, or both simultaneously, which is an excellent opportunity for engineers to, again, incrementally get farther in this process. But once you're hosting on Kubernetes in the cloud, you might find that you're having problems with latency issues. All of a sudden, you're not sitting next to your database that has a 3-millisecond response time. You have to make sure that you set up the observability in possibly new and different ways, possibly using different tooling. So all that stuff needs to come into place as well, and then you can start incrementally shifting traffic between and eventually migrating in full. And from an observability point of view.
Oh yeah, quick note on observability. So we took a little bit of a different approach with Kubernetes when we designed kind of how we wanted to do SRE and observability. So in the past, we've kind of opened up the observability tooling, and the SREs and the other engineers go in there, set up their alerts, set up their dashboards for their product, and we got a lot of sprawl, like a lot of variations. Not that they were bad, but no consistency. So with the Trident 2.0, we exposed an API that could be driven by configuration to set up various really golden signals for your application. So when engineers go in there, they're configuring their Trident pipeline, they can put the parameters in of the things that are important to them for alerting and dashboard creation. And then it fed into our observability API, and then whichever backend observability tool we were using would then configure it there. So the whole idea was to try to get some observability consistency for how teams are doing this. I'd say that journey is still kind of ongoing because there's a lot of different things we have to plug into that API, but so far we've got some wins out of that.
So some of the challenges with the migration have been listed on the screen. So business priorities. You can talk about all these abilities to your business partners and say, yeah, that's great, but I still have a deadline where I need to get this thing done. So that's something that we've been negotiating between technology and the product end at Discover to make sure that this gets prioritized and in place, and sometimes it's caused some negotiation and delays. What I mentioned earlier about introducing the skill level to engineers that hadn't necessarily worked in this way before. As well as teams, when you told them, like, hey, you have to adopt Trident and get to our cloud platform within a period of time, and they don't know, there's just a natural tendency of humans to kind of push back, and it's like, oh my God, I don't know. Like, what's it gonna do? How do I take care of all this? How can I do it in time? So pairing off of what Dean was saying earlier, the community adoption, the inner sourcing, the documentation we put out, we also started presenting power days where we have like more hands-on white glove working sessions across the enterprise where people could bring any questions that they want with the goal of getting them experience for the first time through, and then improving on that, as well as being able to spread their knowledge through other teams or other applications in their area that needed it, and kind of a flywheel effect, as mentioned earlier. So where we're at is our migration continues, but what we've done is with the introduction of Trident, the quality floor has been raised at Discover. The time to deliver has been lowered. People are getting in the habit of, this new way of working where we test stuff in advance, we have robust test suites, and we're building the engineering mindset around software craftsmanship that you build the quality in, you have it ready up front, and always being release ready. We are progressing on that journey, but we're making strides in there. And with these things, that we've now got a standardized hosting platform, and we've got an enterprise level pipeline, that standardization kind of fills your base commodity needs for hosting applications, and it unlocks the creativity within that. So engineers don't have to be snowflakes, they can still find creative ways to work around or inter-source contribute, and that is going to continue to take us farther and farther on our journey.
Yeah, and just a couple more learnings, like I mentioned earlier, it's your platforms where your applications run and your CI/CD capabilities are really cohesive, right? So think about if you're bringing in a new platform, how you want your teams to deliver to it, what capabilities does it need. Go have those conversations early on. I think it's worth the time because we've seen it both ways at Discover, and it turned out much better when we took that time. And your adoption messaging really needs to resonate with your audience, right? We got a lot of feedback that it wasn't right the first time. So engage with your core teams at Discover that are passionate about this stuff and get that feedback. And a lot of surprises came up along the way. So I think in hindsight, I wish we would have better understood the needs of some of our application teams. Because what we discovered is even with the executives pushing for adoption, we weren't ready for some of the capabilities that these teams needed. We didn't do that enough pre-work to really understand that. So that push to have the enterprise adopt a single way to get to Kubernetes and Trident 2.0, that's not how it ended up. It ended up being there's probably 2 or 3 ways to get to Kubernetes. And that's okay, but we consolidated down greatly. We learned the other features that we need to bring into the pipeline, and so that journey just keeps going. And overall, I'd say having the enterprise pipeline really helps us out from like what we said, compliance, audit security. I know I love talking to the auditors now. It's much easier. But also, I think having an engaged community with your engineers is critical. Some of the major components that we have inside of Trident Pipeline were not created by the core team. They were partnered with the core team and contributed by application developers. So, that's it. Thank you very much.
Thank you.
Are you doing this?
All right. You guys are lucky we got a schedule to keep because I got a microphone and a ton of questions.
Save it for the open space.
Yeah, so you might find me at Riverwoods.
All right. Thank you.
So now we're going to do our sponsor break.
We are. So our first platinum sponsor is.
Discover.
Oh, hey, come back here. You got to do your sponsor pitch now.
Oh,
I was
trying to give the low-key symbol. I was like,
That was planned. All right. Hey, you already mic'd up. Amazing.
That's right. We're ready to go.
I feel like
So
I'm
anyway-
just here.
So
Our
Team Parks.
platinum sponsor, Discover.
Do you want to kick it off? You want me to?
After you.
All right. So we're Dean and Craig again. We're excited to be here this week. Yesterday was awesome, so it's been fantastic to be able to talk to you guys about our journey. We want to talk a little bit about Discover itself, but let's see. We talked about so we want to plug our booth. So if you're around today, if you haven't stopped by the Discover booth, please come by. You haven't noticed there's a lot of Discover shirts around here, so we got plenty of people for you to talk to. We also got some cool swag.
One of the things we want to talk about is the Discover Technology Academy, which everybody can access by technology.discover.com. Just trying to share the message of how we're building a tech hub within the financial industry. On technology.discover.com, you can see profiles of engineers and kind of some of the ethos and projects that we're working on to kind of further the engineering discipline and creativity within Discover.
So a little bit about our company. We aspire to be the leading digital bank and payments partner. Our mission is to help people spend smarter, manage debt better, and save more so they can achieve a brighter financial future. And there you can see our values on the right. I won't read those to you.
But they spell out Discover.
They do spell out Discover. It was very clever. Go ahead.
And we're more than a bank. We're a tech playground. We have innovation from engineers. And at Discover, we work in small, autonomous teams that are tasked with meaningful work. And our projects directly impact consumers and make a meaningful difference in people's lives through financial services. We focus on learning, innovation. There's direct access to senior leadership at all levels of the company. And as mentioned earlier, because I didn't read these slides in advance, the Discover Technology Experience was launched in February. It is publicly available and spotlights people and processes at Discover that build our products. So it includes open source contributions, application development, automation, cloud, which you might have heard about a few minutes ago. And within the Discover Technology Academy, we have a community built by engineers for engineers to help improve our software craftsmanship, improve our products, and grow everyone's careers within. And there's also the Discover External Eminence Program, otherwise known as DEEP, which highlights some of our best and brightest at Discover while gaining people at Discover visibility to be able to expose themselves externally at conferences like this or publications or patent applications, all those kinds of things.
Yeah, and I'd say, check out our Discover, technology site. There's blogs out there from, we talked about Trident earlier. The product owner for Trident's got a blog out there, so check that out. It's pretty cool, and various other kind of write-ups. So Discover is an amazing home for engineers just like you. Come check out our website, check out our booth, and yeah, thanks for letting us talk, and hope you enjoyed the presentation earlier.
All right, big thanks to our platinum sponsor, Discover. Up next, we've got Observe.
Observe.
All right, I only got a minute, so I'll be quick. So the problem with observing modern cloud-native systems and applications is the explosion of observability data and the complexity that comes with that. It's centralizing that data in one location, not being able to centralize that data, and for easy correlation. And an economic model, there doesn't seem to be an economic model that scales with your business and scales with this explosion of observability data. So what we did at Observe is we built a highly elastic observability cloud, specifically built on Snowflake, built on a data lake. And it's built specifically for all three pillars of observability, plus other contextual data that'll help you troubleshoot. With automatic correlation built in, and a unique model of separating storage and compute, which allows you to scale much more cost effectively with that explosion of observability data and with your growing business. So for what that looks like for a customer like Capital One is saving them several millions of dollars in subscription a year, consolidating 3 tools into one observability solution, and reducing MTTR from about 2 hours to 45 minutes for their Sev1 issues. So come by the booth right across there. Love to talk to you about it more.
Thanks to Observe. Next up, we've got Tailscale.
Good morning, DevOpsDays Chicago. First off, thanks to organizers, volunteers, speakers, and sponsors for a great one so far. All right, scene, dark basement, hacker hoodie, it's up, mechanical keyboard noises. Exactly, thank you. And then that phrase, 2 words, I'm in. You keep on laughing, but it's much less funnier when what they're in is you. Let's keep that from happening. All right, Tailscale. How many of y'all use Tailscale? Hands, please. Yes, love to see it, but not enough. If you do use Tailscale, please come to Jackson 19 and let us know how, and enter to win a Steam Deck. If you don't, ask one of your friends that raised their hands. Also, free Tailscale at the booth for 100 devices. What is it? If you're here, most of your computers are elsewhere. How do you securely access them? If you say, I don't know, that makes me sad, and you sad at the same time. Come see us at Jackson 19 and hear how we can do better together. Word, salad, lightning round, cloud init, Terraform, SSH, VS Code, Steam Deck, passkeys, Raspberry Pi, bare metal, access control lists, tailscale.dev. Come see us at Jackson 19. Win a Steam Deck. You have 3.5 hours left. Would love to talk to you further. Thank you, and good morning.
It's like verbal SEO right there. All right, up next we've got Jessica Kerr.
Thanks, Jeff. Got this one. Good morning. Yes, I am Jessica Kerr, and I am here to talk about putting your running software on your team, because I think a big part of the point of DevOps is that we can't develop software without also running it and do both well. As a developer, my objective is to provide useful capabilities to my customers, internal or external. And in order to do that, I need the software to be running in production. Okay, so it's a teammate. Can I make it a good teammate? Now, what I love about being on a great team is how much I learn from the other people I work with. And we learn from people by like talking to them and working alongside them and stuff. And so if my software is going to be a good teammate, I want to learn a lot from it. I mean, it learns from me because I change it. That's my job. But how do I learn from it? It's harder than learning from the people on my team because we have this barrier called the line of representation. This comes out of the resilience engineering community. And the line of representation is like that distance between the social and technical parts of this socio-technical system that limits how I can interact with my software. Until Tron is a real thing, I can't just get down there and kick it when it's not doing what I want. I'm limited to my screens and my mouse clicks, so the IDE is one way that we cross this line of representation. Our log aggregators, our deploy buttons in Jenkins, these are all little pathways through that line of representation. So if I want my software to teach me what's going on inside it and how it works and what it needs, then I've got to make new ways to cross this. I've got to make it deliberately show me what I need to know. And do you ever have like an intern who's like trying really hard and also trying not to bother you? And so they're like working away for a week, and on Friday you're like, ooh, I should probably check on them. And you go and there's just piles of code everywhere. And you're like, oh, I forgot to tell you about the authorization service. That's not what I want my code to be. You know, I want my code to constantly update me on what's happening. I want it to tell me what's failing and what's so slow and how do things really work. And then I can use that stuff to like reduce downtime and improve performance. And for onboarding, I can find out not from diagrams, not from reading a zillion lines of code, but from the production software directly, how does this work? This also helps my team accept responsibility for new pieces of software that we need to maintain. We need it to tell us what it's really doing. And as much as I love like solving puzzles and using my deductive skills, it's not enough if it's physically possible to work out what's happening from some dashboards and a lot of logs that we can search through and compare with the code and eventually figure it out. I don't want to be the detective. I want to skip to the end of the detective story and read the confession. That's observability. Okay, so observability definition is we can see what's going on inside of our system because it tells us, deliberately tells us. And in order to do that, we need telemetry. So telemetry is the data that the system sends us. Just us, it's not production data, it's just for developers and operators. And this word comes out of rocketry, or drones these days send flight telemetry to tell you how high they're going, so you don't have to get a cop up in an airplane to find out how fast the missile's going. It tells you. So we need that, and that comes from instrumentation, which is code that we put in our software to teach us what's happening. And that can be as simple as a log statement. A log statement is telemetry. It's not the most useful, but it's a clue. Oh, and we need one more thing, because we're not flying a single rocket. Our software is talking to other software. And in order to know what it's doing, I need to know why it's doing that. And for that, I need to pass some data with every network request to be able to link up the stories of if the front end called the checkout service, called the cart service, I needed to tell me where that came from in order to piece the story together and make its confession coherent and believable. So that's called propagation. Once we have these things, we can get distributed tracing. Now, how many people have looked at a distributed trace? Okay, maybe more than half the room. And a lot of developers are like, what is a distributed trace? So, quick primer. A distributed trace is like if you took some logs. So here's a checkout request coming in, and you're going to log whenever you receive something, and you're going to log about what you're doing, and maybe you'll log when you call the database. But if those logs can be connected with that causal data that's propagated around so that we know what caused what, we can build a little hierarchy instead of having to search for the request ID and getting a single massive text. This is helpful. And then there's structured logs, so they're going to say like where they came from. And then they're also going to say, more than just when they happened, they're going to say how long it took. So there's a timestamp and a duration. This is going to tell us what's slow, what happened at the same time, what waited for what. Now, this means that it's not as simple as logs, because logs, you create the message, you send it, boom. Here, we're holding something in memory from the start to the finish to put all this together, and then we emit a single event at the end. And that event is called a span. It's a span because it's got a duration, it's got a span of time, and it's a unit of work. And then the spans have like causal relationships to make the little hierarchy. And then when there's an error, you can be like, oh, there it is. It happened down there, and then it was propagated upward. The error went forward. And also, while you've got that span in memory, you can continually add little pieces of information to it that are important. And that's super helpful. So each of these spans actually represents at least 2 log statements, a start and an end, and maybe a bunch more in between where you were like, oh, hey, it's out of stock. And it puts it all together into a story that you can read in a little waterfall graph and stuff like that. Oh, and everything has a trace ID. So this is one trace. The spans go together to make a single trace, and this is a single story. It's a request-response story. And distributed traces are the state of the art in observability. This is like the best we've figured out. It doesn't work perfectly for everything. Great for request-response. Not so much for like event-based, but you can use them for that, and we're working on better things. So this is the best that we have. And with these, we can answer all the questions. We can see what connects to what and how things are working. And when there's a failure, we can get to it really fast. And there's a lot about what is so slow because you've got those durations. So that's helpful. So now I need to show you a distributed trace. And I don't have my computer up here to click around, but you can click around. If you go to jusitron.com/otel, it will take you to, it will redirect you to a big, long, ugly, insecure EKS URL of the OpenTelemetry demo app. And that looks something like this. It's a fake e-commerce site. It's gratuitously polyglot and has entirely too many microservices just to demonstrate what tracing can look like. And so if you click on that and you click on something, click on a tire, okay, maybe that's a lens, and put it in your cart and hit checkout, then you'll generate a trace in my version of the hotel demo on EKS. And that trace will show up in Jaeger. So if you add Jaeger, Jaeger, to the end of big long Kubernetes URL, you will see something like this. Or no, you will get to the Jaeger interface, which may well give you an error. It's a demo version of Jaeger. Jaeger's not that bad, really. But if you manage to find a trace and click into the trace for your checkout, it'll look something like this. And at the top, you've got the front-end request, and then here's all the different parts, and you can see it going through checkout service and cart service and product catalog service, and the gratuitously long journey of a checkout request in a fake e-commerce app that goes nowhere. But this demonstrates the instrumentation and the kind of distributed trace you can get from OpenTelemetry, which we're going to talk about more in a minute. And then when you click into one, you can see a bunch of attributes. So you click on like one of the rows here, one of the spans, and you see a bunch of attributes. This is fine. Like the URL and things like that. So you can get into the details. All right, now, more on how this happens, like the specifics of it. So our goal is observability. For that, we need telemetry, and for that, we need instrumentation. But of course, it's not this easy. The telemetry doesn't magically enter our brains to give us that observability. We've got that line of representation in between. So we need that back end. Okay, here's a piece of terminology that I do not approve of, but here it is. The piece of this whole process that you actually look at, that actually gives you a way to query and dig into your observability data, is called the telemetry backend. It includes the front end. But from the perspective of the telemetry, it also includes the database that it gets stored in. So that telemetry has to go somewhere. It goes into some database, which is usually tightly coupled to the front end that can query it. And now that whole part is your observability vendor, and that's not what I'm talking about today. I'm talking about the side that runs in your network. Because this yellow database can be anywhere. It can be in your network, or it can be a SaaS provider. But your code is green here, is running in your VPN, and it's sending some data. And we would like that data to be in a standard format. That would help, because observability is best when it crosses all your systems. And there's usually some pipeline involved. You usually want to process this data, maybe check for PII and make sure to strip that out if someone accidentally included it. So there's some like pipeline and decision making in there. And then there's propagation. Propagation is happening between your services in your network. So we would like all of this to be standardized. These protocols, the pipeline, the propagation, and one more thing, which we'll talk about in a minute. All of these, you want to be, like this is running in your network, you want it to be open source, and you want it to be industry standard, so that that yellow database, that telemetry backend, you can switch that out between vendors and not be stuck with just one. The pipeline includes agents as well. You might run agents on the machine that are emitting metrics about how the node is doing or whatever. But all of this you can find in OpenTelemetry. So OpenTelemetry is the modern industry standard for distributed tracing. It includes those protocols, also logs and metrics, but tracing is the important part. It includes those protocols and the pipeline and the other P word, propagation. Yes, and it's formed like 5 years ago when there were multiple standards for distributed tracing. You've got Jaeger and Zipkin as backend solutions with their own formats, and then you've got OpenCensus and Open Tracing, and then those people came together and were like, this is dumb, we really need just one. So let's make it and call it OpenTelemetry and put it in the CNCF. So OpenTelemetry is now the second biggest CNCF project by contributions. What's the biggest one? Yes, Kubernetes. Okay, but OpenTelemetry is not specific to Kubernetes at all. It works in Kubernetes fine, but it also works everywhere else. It's a lot of different things. It's got all the governance, blah, 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 that comes with the CNCF, very industry standard, very not proprietary. It standardizes the protocol that's called OTLP, which stands for Open Telemetry Protocol. The L is silent. And it's got a collector process that's configurable to do a zillion and one things, including running as an agent. And then, like, the propagation standards are actually even higher up. At least for HTTP, the standard header for trace context propagation is specified by the W3C. So this is getting increasingly standardized. Other messaging protocols have their own standards for how to pass that information. But all of this is inside OpenTelemetry. And then you also need some libraries to put that standard trace parent header on your network requests. And what happens here is, say this top app is Node and the bottom app is Python. OpenTelemetry provides libraries that plug into the standard ones, that, like in Node, they intercept the require. In other languages, they do some other magic. Java, they're modifying the bytecode, whatever they have to do, to plug into the existing libraries. So with OpenTelemetry, my Node app just magically starts adding a trace parent header. And my Python app is using Django maybe as a web server to receive the requests. And Django magically starts reading that trace parent header and using that propagated context to create new traces. And then that winds up plugging into the other libraries provided by OpenTelemetry. So there's SDKs, yeah, they call them SDKs, but this is code that includes like exporters and processors and all the stuff that's going to hold that span in memory until you end it, and then it's going to set the duration and send it. All of that stuff is in OpenTelemetry libraries per language. And in each language, it uses different mechanisms. And then the instrumentation, this is that fourth piece that doesn't start with P. The instrumentation that plugs into the client libraries and the server libraries is going to create the traces and spans, the spans really, to represent the network request. So every time you have an outgoing net request, it knows you want a span. You have an incoming request, that's definitely a span. You send something to the database. Let's plug into your Postgres client, and we're going to create a span, and all that comes together in the SDK. And then the exporters ship it to your collector, and everything is lovely and standardized and intercompatible with all the existing formats. The collector does that too for migrations. Now this takes a different format in every language. So like in Node, it's pretty easy to intercept, require statements, and just cram code in. In Python and Java, you can do this from the outside, like with a Java agent. I don't know what they call it in Python, but you can wrap the actually invocation of the service. So there's a Kubernetes operator that if you have Java and Python microservice app deployed in Kubernetes with this one piece of magic YAML, you can automatically add tracing to all of those and poof, get a whole distributed trace. In Golang, there's a lot less magic allowed, so you actually have to like instantiate your HTTP client differently to wrap it in the OpenTelemetry with the middleware. So it varies, but the goal is to instrument everything. And this is why OpenTelemetry is such a big project, because it's a zillion projects. Okay, it's a couple hundred projects for all the different languages and all the different frameworks. And this is another reason why it's so important that this be an industry standard. Because at Honeycomb, we don't want to write our custom agent for every language and every framework. No, let the community do that. So instead, we do a lot of contributions to OpenTelemetry. And this gives you the scaffolding. This gives you the outline of the confession of who was where and generally kind of what they did, or at least who they talked to. And then these spans that it creates include standard stuff that it knows you want, like the URL and the user agent headers for what browser. But it's not going to put on all the headers because that could have PII in them. You need to put on the headers that are important to you, and you need to put stuff out of the body of the request that's important. So put your customer ID in here. Here's like The demo does have some custom instrumentation added, so it's got like the order amount and the items count, because that's going to affect how long things take. So if things are slow with big order amounts, you want to distinguish those from the small ones. So this is what really makes instrumentation pop, is when you add a few custom fields to that active span that's already in memory due to the automatic instrumentation. So an immediate question that I always get is, okay, but how's the instrumentation for my language? And it varies. So it varies like what state all these different open source projects are in. So you can go to opentelemetry.io/registry. Here's the trick. Scroll down. There's a search box. It's not above the fold. Scroll down, type what your language and framework, and hit search, and it'll take you to the repository that has that. Most of the languages have a really solid level of the SDK that's typically 1.0 at least for most of them. And also a contrib repository with instrumentation for a lot of different things. Most of that is actually also pretty solid, but they'll let things into contrib sooner. So yeah, check it out. Look at the GitHub repo. Look at the stars and the contributors as you do for open source projects. There's a lot. Yeah, these languages are documented on the OpenTelemetry site. Okay, in summary, do this. Use OpenTelemetry. Oh, I forgot to tell you yesterday. Gabriel said in one of our open spaces that is for his observability, he's very worried about costs and also about serving a lot of different audiences. And he's like, whatever observability tool the executives pick, my thing is make them use OpenTelemetry. Use OpenTelemetry everywhere, and then you can fight over what vendor to use later. You can cost optimize your vendor. You can send it to multiple different ones if you really want to pay for both. You can have that. You can run Jaeger in-house, or you can try different SaaS tools. So super important. And that means use OpenTelemetry throughout your applications. It is the standard. Every observability vendor supports it to some degree, and that trend is increasing. Now, this is a sample initialization of tracing in one of my little programs. You're photographing this. Don't do it just like this. You probably don't want to modify the batch span processor configuration. I'm doing that for nefarious purposes. But you may well want to instrument or specify the automatic instrumentation you want, especially if you want to keep your dependencies down. So here I'm like, okay, use the HTTP instrumentation and the file system instrumentation. Don't bother loading in the database client and stuff like that. And then absolutely augment that with custom attributes. Okay, this code is actually okay. So in this case, I'm pulling the active span out of thin air. OpenTelemetry is generally good for plugging into whatever thread locals or globals your language supports and giving you the active span. And then you can add attributes to it that matter to your application. So here the image height and width are very relevant, and I want to know that information about the image that I just read in. And then also create custom spans sometimes, especially if your application is not using a standard web framework. Here, this is a command line utility, so it's doing its own thing. So I've wrapped all of the major steps in a span so that you can see a nice layout of what this program is doing. You can see what took so long. Okay, what's in check authorization? Oh, there's an HTTP call. No wonder it took so long. Where did that go? /auth endpoint. Okay, I'm not too worried about those 200 milliseconds. But actually, earlier, there used to be 3 calls to this auth endpoint. And then I noticed that, and I refactored the code so that it only calls it once. That kind of thing is really easy when you have tracing. Do make your own functions to wrap the OpenTelemetry span creation. So here's my main method in that sample program, and it's doing a lot of spaninate around each step. Now, I don't particularly recommend the name spaninate, but it made me happy, and this is my program. So here's one implementation of spaninate. And in these wrapper functions or these shared libraries, a lot of companies create shared libraries to make their traces look more standard and use like standard field names for things. So do add fields that are useful. Maybe you want to add like the CPU usage and the memory level right now. That's relevant to the functioning of your app. In this case, I'm like instantiating an error in order to pull the code location off the stack trace and cram that into the span. I mean, maybe you want to do that in debug mode, but I'm just having fun with it here. And then once you have that instrumentation, you can graph the traces, but you can also be like, okay, overall, in all the runs of my silly command line program, what was slow? And I can look at a heat map for that. Heat maps are a really fun visualization that a lot of people are not familiar with. So happy birthday, you get a heat map today. In a heat map of duration, higher is slower, higher duration, and darker is more. So I can see that the main events are the slowest here, and there's that check authorization and that HTTP GET that are slow. That's pretty consistent here. Now this is a weird looking heat map because it's just me running my command line program that many times over 2 hours. Here's one from the OTel demo. It looks a little more normal. You get like a smooth distribution. But this shows you not just the P95, not just the average, but all of the requests by duration are showing up here. And so you can see that the darker line at the bottom means most things were fast, and you can see how many were slow, and you can look for patterns. Heat maps are really fun for that. They draw a picture of the overall distribution of latency in this case. Speaking of drawing a picture, you could technically like draw a picture in the heat map, and that's what this little program does. If I run it with the DevOpsDays configuration, then it's gonna greet me with a cow. There it is. And then it's going to give me a link, and that link goes to a heat map. And there's the DevOpsDays logo. And if you click on the heat map, you get the trace of that request. And the trace has a poem about DevOpsDays. It's a terrible poem. ChatGPT wrote it. But to see the whole thing, you can run this program yourself. You can hook it up to your free Honeycomb account and generate your own heat map. So remember that while I said you could do this, I did not say you should. But you can. You can. That's actually a little older version of the heat map. I've tweaked it since then. And you can make your own pictures in your own heat map. And the instructions for that are here. And yeah, your 7,000 spans will not come close to maximizing your free Honeycomb account. So this is safe and fun and familiarizes you with heat map. But the important thing is to use OpenTelemetry in all your applications. Thank you.
That was amazing. Because I don't want mysteries, I want confessions. That Jessica just wrote your whole project charter, right? You just copy and paste that everywhere, right? And anyone that argues with you is clearly off the deep end. Okay, so it's time for a break. So we're gonna get up, stretch our legs, grab a snack for those that weren't here yesterday, and just a reminder for those that were, there's nourishment stations sort of all around the conference center, so feel free to grab chips, single packaged Swedish fish, whatever monster created that idea. You know, help yourself. There might be sodas in the doors. Those are also fair game, so if you see an unopened soda or beverage, feel free to take it. We'll meet back here at 10:40, and we'll pick up with our next talk. Thanks. All right, we're going to give folks a couple of more minutes, but then we're going to go ahead and get started. So if there's any chance that you're in the periphery and you can hear this, start making your way in. If I stand on the stage, it'll look like we already started, and people will be like, oh no!
I'm coming.
Oh no, take your time. I was like, we'll give people a couple minutes, let them filter in. I saw a good lot of hallway track conversation going on, so that's always exciting. We're slowly filtering in.
Slowly making our way.
It's all the free Diet Coke.
It is. So yeah, we got two more talks this morning. We'll have some lunch. We'll come back to Ignite, some raffles and giveaways. So during lunch will be your last opportunity to enter all the sponsor drawings, get your sponsor passport filled out. We're giving away some awesome prizes. Sponsors are giving away a lot of awesome prizes, including one I saw is giving away a pair of custom Nikes. That seems pretty rad. That's leveling.
come in
Everything's
15?
leveling up. No more drones. Right? Drones are over, right? But yeah, and also for your sponsor passport, we've got a Nintendo Switch. We've got a cool Lego kit. We've got some autographed copies of Jeff's book. It was funny when we were talking about offering that, and one of the organizers said, well, would it be weird because Jeff's an MC? Would he feel weird like saying he's giving away his book? And Jeff's like, I would not feel weird at all.
Not at all,
be fine.
because I got all my books right when the pandemic started. So
Yes.
they're like, hey, we're going to ship you a ton of books for all the conferences you're going to go to. And then the world has ended. So I've got a lot of copies in my house. My wife was pleased.
Well, I think let's go ahead and introduce our next speaker and get out of the way.
All right, let's get out of the way. We're going to turn it over to Fitz, who's going to talk to us about application layer reliability on top of infrastructure reliability.
All right, thank you very much. So my name is Fitz. I am a developer advocate with Temporal. And there are three things that I'm going to talk about today, applications, infrastructure, and reliability of both. Now, a couple things there before we get into it. Infrastructure is funny because we know it's reliable, but we also know it's unreliable, partially because of the tools that we use and because of just the nature of things running. And so we'll see in a moment, I'm going to simulate some unreliable infrastructure to show some of how that unreliability is manifested in reliable things, with Kubernetes, and then how we can have an application running on top of that reliably too. Now, speaking of that application, we need something to run, and so I'm going to build or show today a customer loyalty program. So these are fairly common programs where you as a customer can interact with some company and earn points, earn status, say flight miles, number of rides, number of tickets bought, number of coffees bought, whatever it happens to be, right? This is fairly typical. And when you earn some number of points, you're going to then also gain some status. So we have a number of different pieces of state here that we are trying to maintain for each customer in the system. We have the number of points they have, we have the status that they currently have. Maybe each one of those tiers of status affords some kind of reward, like maybe being able to invite other people to the program. Like if I'm platinum tier, maybe I want to invite someone and then gift them gold tier potentially. And so then I have more state as well, so I have my list of guests that I've invited to. There's a lot of state that's being maintained here. Okay, That's not a problem. We know how to build applications that have state in them, but how would we build it? So typically, we're going to have customers, right? For better or worse, customers exist. They're going to use our stuff. And they're going to hit some kind of front end. We have a login or auth provider, some kind of load balancer. I'm not going to talk about that stuff today, but it's important to mention that it exists. It's there. And potentially we might have that routed to some kind of events processor or stream processor where we're just going to pop a message onto this queue, Kafka, RabbitMQ, whatever you happen to be using, in order to then be processed by a bunch of consumers, which are potentially going to write out to some database, right? So this architectural diagram doesn't look that complicated, right? It's not that different than many architectures we've seen out there. But when we start to break it down and ask things like, well, what are your consumers doing? Where are they running? Probably in some sort of Kubernetes node pool where they're just going to be running somewhere. Great, okay, that's fine. How are we going to deploy our events front end and our streams processor and our load balancers and our databases? There's all sorts of questions here that come into play when we start to actually implement this. And more importantly, when I have the entire architecture here, the problem that I am trying to solve is to build a customer loyalty program. Nothing other than the set of customers here on the left communicates that this is a customer loyalty program. I have a bunch of technology, which is great. We are technology people. We are engineers. We love technology and love building technology. Awesome. That's great. I love technology. But nothing about this communicates that it's a customer loyalty program. Nothing here represents a customer other than the abstract stick figure that I've drawn crudely on the left. That's it. And so I'm a programmer by trade, and I teach programming in my side job. And I love talking about programming, thinking about code. And what I'd really love to see is something that looks like this, where we just have an object or a struct or some sort of programming construct that represents a customer and what we can do with it. Right, so we have something called a customer. We can add points to this customer, mutate that state. We can potentially invite some guests if our status allows for that. We can cancel the account. We might not like them to, but we can cancel the account. We can query for their current status, and that's what we want to do. This is the representation of the program, okay? That's what I'm going to try to get at today. And so we're going to, in many ways, focus on the application layer. But before we really get into the application, I'm going to pop out of the slides and come over here. That's a preview for the code, and show that I have, like all good cooking shows, a complete final version of this application running. And I've been simulating load on this application for a few hours now. I started it early this morning, and it's just been there running. Hopefully my battery lasts, because we're on battery up here. But I've been simulating some load, some customers that exist in the system that are earning points, potentially inviting other customers. We can see here that I've mitigated the load because it's running on my laptop. Somewhere in here I have a dashboard, because we love graphs and dashboards too, so we can see how much load my laptop is having. So I have some load here running on the system. And in this dashboard view, we can see the actual customers running, where each row in this table represents one customer in this program. And if we click on one that's existed for a little while, we can then also see that, hey, this customer has started, they've received some points, they maybe even got an email that was something like, welcome to our program, you're at bronze status, because they were invited by someone who already had status and got some higher status. So this program exists, this application exists, it's running, and what it happens to be running on is, this is probably familiar to a lot of people, this is the Kubernetes dashboard with a couple of pods running. I have 4 pods running. You can see that they've been running for a few hours, where I started it this morning, and it's been running perfectly fine. So we know Kubernetes can, one of its promises, right, is if I configured it to have 4 pods, it's going to make sure there's 4 pods. Let's stress test that a little bit. And of course, let me copy my command here and create some chaos. Now, I know this is a little bit of a gimmick, but because, Kubernetes, this is what it does. I'm going to delete the pods, and it's going to bring them back up. And we can see now also that 11 seconds ago, 6 seconds ago, we've gotten new pods out of this. That's fine. Kubernetes is doing its job. Great. We have our reliable infrastructure. Check. We can check that one off of the agenda. Cool. Okay. And I'm going to take a brief look then also at that load script. Script, simulate, load. There's a lot here. The important things that I want to call out are I am actually checking for errors in this system. So this is a simple bash script. I'm just checking for the error codes coming back. It should be logging any errors if they happen. Okay. Now on the left, we see that script running. No errors have come up. Our infrastructure is doing what it needs to. Things are restarting and going along just perfectly fine. And if we go back into the runtime dashboard and see, I don't know, the latest customer, things look perfectly fine. They were invited. Here we go. You were starting out at silver status. Everything seems to be running perfectly fine. Okay, great. Now we're going to start looking at implementation details for this application. And there's a couple things that I want to talk about before we really get into it. So I'm going to propose an implementation model called the actor model. And who here has heard of that design pattern? Okay, a number of people. Great. For those who haven't, I'm going to quickly overview what that means. We're going to look at a little bit of implementation, and then we're going to wrap things up and summarize. So actors, what are they? Actors were originally designed and conceived of in the 70s by some researchers who were looking to build some AI models. And yes, AI has existed since well before GPT. But they conceived of this principally because we needed a way to segment computation and isolate computation in a way that made sense and still allowed for things to communicate with each other. And they formally define these things as having three qualities. First, that you can send and receive messages between different actors. You can create other actors, and each one can also modify its own state. These are the three qualities that formally define an actor. Now, when I see this, it reminds me of another programming construct that we're all relatively familiar with, objects. Right? Objects can have methods and call other objects methods. They can create other objects. We can instantiate using new keyword or whatever language happens to support for creating objects. And they can have instance fields where we can modify and store a state. Right? So when I'm talking here about actors, I want you to, in your head, replace that in your head with objects. And I'll verbally do that a couple of times just to remind you, but actors and objects are more or less the same. Obviously, there are differences, but for the sake of this talk, actors and objects are the same thing. So diving into that a little bit more deeply, there's a couple things that I want to point out. First, that sending and receiving messages thing. There's a few things that we're going to want to keep track of in terms of our application. First, we're going to want to know what the address of those other actors are. We need to know where to send those messages. We need to know how to act on them, what we're going to do with those messages. And also importantly is that those messages can arrive in any order and asynchronously. That's also very important because when we're building this system, there's a reason that many architectures end up with this events processor or queue in front of everything, because things happen asynchronously. Things happen out of order in any order, and we don't know which customer is going to earn points when, right? This happens asynchronously. Now, when I hear that word, it makes me also think of concurrency and parallelism. Who here feels very, very comfortable with the difference between these two words? A couple of hands? Okay. So in my free time, I teach computer science, so we're going to go briefly into a computer science lecture. Bear with me. Parallel and concurrency, they are very closely related, but they are also very different. Parallelism is the idea of things are literally running at the same time. I am walking and talking at the same time. Those two functions are happening at the exact same time. You are also sitting here listening while I'm talking. Those things are happening in parallel at the exact same time. That is parallelism. It talks about how things are running. Are they literally running at the same time? If yes, they are happening in parallel. Okay. Concurrency, meanwhile, is more of a design idea. It's more of a how is the program structured, how is the runtime structured in order to handle multiple things. So it doesn't really talk about how things are run. It talks about have you designed things such that our different functions are isolated from each other, such that they can run in any order. Remember, I mentioned that earlier. And mostly independently from each other. They can interact, but not necessarily. That's not a requirement of concurrency. But they can interact. Principally, they are happening independently of each other. So if I have concurrency and not parallelism, I would talk, and then I would walk, and then I would talk, and then I would walk back. Those are two different functions, and I can do them in any order that I choose. It doesn't matter what order they happen in, and they're happening independently. Likewise, this is what we think about when we think about multitasking with humans, where multitasking is sort of possible, but not really, and the way it's actually possible, right, is I go and check email, I pause it, I go and check Slack, I pause it, I go and write a line of code, I pause it, I go and check Slack, I pause it, I go and check my email. I'm never actually doing those two things at the same time. They are not happening in parallel, but they are happening concurrently and in any order, and that's concurrency. Okay, now this is important because when we think about objects and actors, they can happen either in parallel or concurrent. And so when we think about the actor model, one of the important questions here when we go to implementation is this happening concurrently or in parallel or both? Who thinks it's both? Great, yes, thank you. That was the question, both. It is happening both simultaneously. And that's because if you have multiple actors, say customers in a loyalty program, if I were doing it serially, not in parallel, one at a time, but potentially concurrently, handle customer 1 and then customer 2 and then customer 1 and then customer 3, independently like that. You could do it serially, and that's fine, I guess. But if you end up with thousands or millions of customers, that's not fine anymore. So we have to have an implementation that's able to handle these in parallel, in any order, independently from each other. That leads us to both parallel and concurrent. Okay, that was your CS lesson for the day. So that's one of the other concerns we're going to look at in the implementation. And then finally, these things have to exist in some manner, in some way. And so if we're going through, and remember, if I go backwards through all of this, back to this is the construct that I really want to have. I want to have some kind of programming construct that just says, this is the customer, and if we think about it in terms of an object or a function, it has to be running and instantiated somewhere, right? It has to exist somewhere if this is my goal. So, which slide? That one. They have to exist. And when we're looking at our customer loyalty pipeline or program, there's no definition of how long they need to exist. They could exist forever. Okay, so now we need a programming construct that can exist forever. And the moment that I think of something existing forever, I'm like, nah, that's not going to happen. Yes, I can have that Kubernetes node pool existing for as long as Kubernetes is running, and it'll make sure that all those pods are up and running. Sure, that's fine. But the function that's running on top of them, it's being canceled and restarting, and it's not really existing forever. So that's a weird thing, but we'll come back to that. Now we're getting into implementation a little bit, okay? So we're going to write some code. Reminder, mentioned a few times, we're writing this customer loyalty pipeline program, and if you want to check out the code that I'm going to dive in, that's the QR code to the GitHub repo that is hosting the code. It is implemented in 3 different languages, Go, Python, and Java. So if you write not one of those languages, I am sorry. But hopefully between those 3 languages, you can get an idea of some of the patterns. We're going to look at Go today and see what this looks like. So again, I've got my simulated load happening over here. Nothing seems to be airing out, which is great. And the live demos are with me today, I suppose. Now, I'm going to check out my not final fully cooked chicken and go into my code. This is my customer loyalty thing. This is a single function that is going to represent a customer. So an invocation of this function represents a customer. Everything within this function, all the state that is handled in this function is going to be for one customer. You can notice that I'm passing in a customer info, and that particular thing has things like the ID and how many points it has and which guests it's invited. So that object is my customer. Now, typically, if I'm going to, say, kill a Kubernetes pod and restart it, I would lose all of that state and have to recreate it somewhere. But bear with me, we'll get to how that is not going to happen. So just taking a tour through this a little bit, we have a couple of helper things going on here with, like, if it's a new customer, then we're going to send the welcome email. If it's not a new customer, move on. And then we have a couple of these what are called signal handlers. And I'll get to what those mean in a second. Importantly, one of those things is to simply add some points, mutate that state. Remember, the thing that we have with objects and actors is to be able to mutate state. Change what I do in response to certain messages that are being received, and potentially what messages I send. So I need to be able to mutate this state, and quite simply, I am just going to use my VS Code snippet and add some bunch of code. There's nothing special going on here. These are just some helper methods to calculate how many points I have and which status level I need. That's just a simple for loop going through a list to say, which status am I? There's nothing special about that, and saying, here, if we increase our status, send the, hey, congratulations, you've been promoted email. And if that status has demoted, fortunately, I'm not actually simulating any negative points, so that's never going to happen. But in the case that it did, we want to be able to send that as well. That's my method. That's all that I'm doing for being able to simulate adding those points in. And so that's the adding points method. If I go down to my other to-do of, okay, we added our points. If I cancel account, the other thing we want to be able to do is, should the customer want to close their account, we want to be able to handle that case as well. That simply, if we're just modifying state, let's just modify our state. That's it. So my claim here, my persistent claim here, is that I have a function that has some state. All I have to do is modify it. All right. That to-do is done. And so this, I have a, or I did have, let's go here. I have a uncooked turkey, if you will, version of, so this is running with temporal, and this is our development dashboard that you can see all active workflows running. And so this is our development server, and I have nothing running because I have not started anything. And as in all things, we need something that exists that actually runs the code. And I'm going to run my go into my app, run my worker. This worker process is simply failing to do anything because, no, it's working fine. Okay. Note to myself, I had an if statement in there to check whether we're running in a Docker container versus running locally. So saw the error, and we're actually running locally, so not in the Docker demos. So now we have something running that is actually going to be able to run the code. So no matter what thing you're doing, right, something has to exist to run the code. You know, we talk about serverless sometimes and Lambda and things like that are running serverless, but the thing still exists in some manner, right? You call out to Lambda in order to get that thing to run. So in this case, we have this worker process running that is going to actually run the code. That particular, just for our own edification, that particular code is not very complicated. I create an API client and then instantiate or register which code that I'm running with it, and then run it. There's nothing special about this. I just say, here's the class that I'm able to run, function in this case because it's Go. Here's what I can run. be available to run it. Okay, now I have something available to run it, and I'm going to then also start off a particular instance of this function. Now you could imagine this thing happening from that cloud of customers out and about, where someone is actually interacting with your app. They sign up and they kick off some sort of call to the client to make sure that this can start an instance of the customer. So when I do that, now I'm going to have one instance of the customer. And so that's the basic starting of this. I now have a customer. Nothing has really happened here, in part because we're picking up my Kubernetes workers, which have a different set of code. That's lovely. The demo gods are not with me today. Okay, but so we have a customer running, and that's just an instance of that function. If we actually let's go look at our final cooked turkey. When we start off an initial customer, let's go and look. I've got 250 of these running, but one of them is actually my seed customer. When those initially start, at the very beginning, those can just receive those messages and see that we're adding points. And note that I am able to, here, let's actually make this work. I'm going to change where I'm running this to my demo and restart my worker. We can allow through the firewall. I'm running this on the demo queue. And if we go there, let's restart these things because I'm changing where I'm running it. There we go. I have my customer running, and if I want to add points to them, add loyalty points, I'm going to add, I don't know, 1,000,000 points to customer 1. And see that I'm continuing to restart my workflow. Okay, the gods are not with me. But I'm going to skip ahead slightly to when we did have the cooked turkey running, because if we look at our Kubernetes dashboard, these things have continued to restart while I've been talking, right? I didn't stop that chaos script, and those are still continuing to run, where you can see how many times those pods have been deleted and restarted. And meanwhile, if we look at, say, the most recent customer, they're still able to receive those messages of having added points, or potentially at some point, maybe here in the middle, we've been promoted. Those emails and that state has been persistently maintained, even though that function that I showed you in the code, that's what those pods are running, and that function is being restarted, and I haven't lost any of that state. Okay, so we're gonna go back to the slides momentarily. With these actors and objects, there's a couple of things that we've looked at. One, we can receive, send, and act on messages. That's that add loyalty points. We can see that that function has a function, a sub-function within it to receive how many points am I going to be getting. We can create others. What I didn't show you is that here in the middle of the workflow for inviting a guest, I am then saying, well, given that this guest ID is the one that I want to invite, let's go in and start a new one. So we can create other workflows, other instances of this function from one particular invocation of that function. So we can create other instances of these customers. We can have these infinitely running, as we saw with having my chaos script continually restarting and killing nodes. So these are effectively infinitely running functions with their own state that are separate and concurrent and in parallel, because I have multiple of these pods running. So they are infinitely running. And this has built us up to having unreliable but reliable infrastructure and an application that is able to successfully run on top of it. The summary here is that distributed systems are hard because they're everywhere, they're all over the place. Managing, interacting with all of them is very difficult, but it doesn't have to be. We have tools to ensure that infrastructure is able to be up and running, other tools like temporal, which are happening at the application layer, not the infrastructure layer, can help make sure that these things continue to run and are persistent and keep going and maintain their state. I've already looked at the turkey, just to wrap things up at the very end, again, my name is Fitz. I'm a developer advocate with Temporal. If you want to learn more, we are having a happy hour tonight. If you want to look at more of the code, including my chaos scripts and my simulation scripts, they're here in my GitHub repository, and that's what I've got for you today. Thank you very much.
All right, thank you, Fitz. That was great. It's time for a quick sponsor break. So if our sponsors are here and lined up, I think we're going to start with Noble 9.
Hello. The beach ball is irrelevant. I'm Carrie from Noble 9, an SRE at Noble 9. We do math so you don't have to. And we do that with centralizing all your performance metrics, make them more meaningful using SLOs, and basically make it so your data speaks for itself so that all the people that you don't want to talk to can just look at your data and figure out why you want to do the things that you want to do that already make sense. And we actually have a little game that I'm going to play with you guys real quick in my 20 seconds left. So 25, all right. So this is a game that helps you sleep at night by figuring out whether or not you should accept this page using SLO theory. So this card says if you got page at 3 a.m. With a monitor that said 99% CPU utilization on a Linux server 1 over the last 10 minutes, you could just shout at my face whether or not you would actually wake up for this. Congratulations, you guys win. So this is the correct answer. Go to sleep. Yeah, I don't know. We have a bunch of these. There's a whole deck of them, and you can come pick them up at the Noble 9 booth, and then come say hi, and we can talk about SLOs or observability or unrelated things. Thank you.
Thank you, Noble 9. Next up, a small little startup called Google.
Hi, I'm Amanda Lewis. I'm on the Door advocacy team at Google Cloud. And on behalf of myself and all of us here today from Google Cloud, I want to thank all of you and the DevOpsDays Chicago community, and especially the DevOpsDays Chicago organizers for creating such a great 2 days of listening, learning, and collaborating. We had great discussions at our booth yesterday. If you haven't stopped by, we're just across the way. It's the Dora booth. There you can use the QR code to access the 2022 State of DevOps report. You can benchmark your team's performance, and then you can also join the Google Cloud Innovators Club, and there you can figure out why Google Cloud is a great place to improve your software delivery and performance, and improve your cloud skills with free credits. on some training. And then you can also access the DORA Community of Practice, and I encourage you all to join that so we can keep all of these great discussions and learning going until we can be back here next year at DevOps Days Chicago. Thank you.
Thank you, Google. Next up is Puppet, one of my first love affair communities.
Hey, I'm Ben. I'm here for Puppet today, or Puppet by Perforce, as marketing likes us all to say. Yeah, pandemic brought a lot of changes for all of us, but we've been around for a bit. We've seen a lot of change. So Puppet popularized the idea of declarative configuration management. We helped define this industry that we're in right from the very start. And we're still focused on being that common language that helps people communicate across different teams, and that all those abstraction layers that help you focus on the things you actually care about. So because at the end of the day, DevOps is less about tooling, and it's more about sharing common goals and about common ways of engaging with one another to meet those goals. So yeah, I'm not gonna try to sell you on something. Buy what fits your needs. But most of all, talk with your colleagues. Realize you're all on the same team, and build ways to communicate more effectively. And if we can help you with that, great. Stop by our table for a chat. We're happy to answer any questions. We'd love to catch up. We've got socks and beach balls and a few books from my friend David that we'll be raffling off later today. Cheers.
Thank you. Next up is Cloud Bees. Oh, there you are.
Figured I'd surprise you, come up, sneak up on you unexpectedly. Hey, DevOps Days Chicago. Talked to a lot of you so far today. Good conversations. First thing I want to tell you about CloudBees. CloudBees is more than Jenkins. Some of you may not be familiar with CloudBees, but CloudBees did start with Jenkins, but we handed it over to the CDF in 2019. We are still the biggest contributor to Jenkins upstream, and we work a lot with them. But CloudBees, more than Jenkins. So if you use CI, CD, release automation, release orchestration, feature flags, feature management, if you have compliance and risk management people on your back making you write custom scripts to go in and figure out where some of the risks and vulnerabilities are, we have a product that will help you with that. Also, value stream management. So, I've been talking to a lot of SREs at the booth. If you're an SRE, you have pain. I would love to talk to you. I love hearing about people's pain because I might have a way that we can help you with it. If you're on a platform engineering team, would love to have a conversation with you because our products help a lot of platform engineering teams serve their internal customers a lot better. And if you just want to come over, have a conversation, get a water bottle, get some swag, we have a lot of stuff. We don't want to take it home. You know, just come pick it up and get your stamp if you didn't already. Thank you.
Thank you, CloudBees. Last but certainly not least is Vertana.
Get 2 for 1 on this one. I'm with Cloud EQ. We are a professional services organization. We focus on cloud environments. So if you've migrated to the cloud recently, or if you're in the process of migrating some things, we're happy to help you out. If you need help implementing tool sets, automation, some modernization activities, those are our specialties. So please reach out to us and we'll see how we can help you.
Hi, I'm with Vertana. We have a purpose-built diagnostic system for Kubernetes. So if you don't want to build dashboards and jump into all different kinds of tooling and just pull all the landscape into one place and the supporting infrastructure, whether it be in cloud or on-premise, come see me at the booth and we can give you a quick demo. That's automated root cause analysis to help you guys. You know, we're basically kind of like a Navy SEAL that can fly in, help you solve your issue, and get you back working. Thank you.
Thank you, Vertana. Another round of applause for all of our sponsors. And then we're going to keep it going for Josh Zimmerman for our next talk.
I'm Josh Zimmerman. It's been a fucking journey to get here to talk to you today. I was supposed to give this talk last year, and on the morning of the conference, I tested positive. And 2.5 weeks ago, my 2-year-old brought COVID home yet again. And as of Monday, I was still testing positive. Testing negative now. I'm here. I'm finally giving this talk to you a year later. For those of you who've been to DevOpsDays Chicago before, you've seen me do a series of silly Ignite talks, and that's not what we're doing here today. It's going to be a little bit more serious. And we're going to start here today with a little interactive session. Raise your hand if you like your team being able to make autonomous decisions around the things that your team owns. This should be the entire room, yes. Raise your hand if you like it when other teams make decisions that impact your team and don't consult you about it. Some of you are lying. Now, raise your hand if you like to get involved with organizational politics. There are so many liars in this room. Politics at its core is collectively how we make decisions. When you get upset at a decision another team has made that impacts you, or when you want to make a decision without having to talk to anybody, that's playing politics. But when we're happy with how decision making is happening, we don't tend to think of it as politics. And this is one of the things that makes navigating organizational politics tricky. Now, for those of you who don't do the whole Star Wars thing, this title is a reference to The Empire Strikes Back. Han and crew are trying to escape through an asteroid field, and C-3PO freaks out and tells them the odds that they're going to make it out alive. Han tells him, never tell me the odds, because what other choice do they have? You know, on the one end, they're going to be killed by the Empire, and on the other end, maybe they die by the asteroid field. But this is kind of what it often feels like in our organizations navigating politics. But more importantly, it made it really easy to design a slide theme. So we're going to cover a variety of topics today, including but not limited to this. And I want to emphasize here that when I talk about effectively navigating organizational politics, that doesn't mean that you just get the shit you want. It means that you're fixing things that are broken and that you're understanding what's going on. This is a very large and broad topic, so we're obviously not going to cover all of it in 30 minutes, but hopefully you'll take enough away that you'll be able to positively impact your workplaces. There are also tons of fields and subfields that study this kind of stuff, and they all have jargon. Some of their jargon doesn't overlap with each other. Some of it doesn't overlap with what I'm going to talk about today. So I just want us on the same page for the words I'm going to use today. Power is your ability to do a thing, to make a decision for other people, to force people to do a thing. Power doesn't have to be used to have it, and all of us tend to have a lot more power than we think we do, which causes problems because people don't do the things that they need to. Today, we're going to talk about authority as power that is viewed as legitimate. Legitimacy is obviously pretty squiffy and very contextual. Historically, people would have said that a monarch had the authority to rule their kingdom because a deity decreed it so, or because they were a warlord and they took it over and nobody wanted to go against them. Today, we have things like constitutions and elections, and those are the things that grant our officials the authority to do things. In your organization, authority might be granted by a place on an org chart. But it's important that you know that other things can grant you authority too. Domain knowledge might grant you the ability to make decisions in a domain. An incident might give you legitimacy to take actions that you would not be able to take otherwise. So like, to put this in more terms that we're used to, being able to sudo on a Unix host is power, but you might get in trouble for that if it's not during an incident. And that's authority. So often when we're talking about people who are playing politics, we're talking about people who are exercising power who we view as not having the authority to do so. So this is going to seem obvious to a lot of people here, but to influence what decisions are being made in your organization, you need to start by understanding how your organization makes decisions. And I know you're thinking, Josh, we have an org chart. We keep it up to date, which is a lie. And this shows us how the organization makes decisions. And they can be useful tools, but they're also the lies that we tell ourselves to convince ourselves that our organizations have their shit together. Org boundaries happen to be socially constructed. They change and shift regularly. Viewing the organizational political structure as a static artifact gets in the way of you understanding what's actually going on. Instead, you need to look to map out power and authority throughout your organization. You need to be able to describe relationships between individuals and teams. You need to understand how people and teams work together, and more importantly, when they don't work well together. It's important that you start this not from an org chart, but by doing on-the-ground research, which means asking questions and answering them. You can ask questions like, who was involved in a decision? Was anyone excluded? What did the process look like? Was there an official process? Was that followed? Who does the decision impact? Were they consulted? Who's accountable for the decision? You want to think through all of the possible metadata around these decisions. You're also not always going to be able to answer these kinds of questions alone. So, sometimes you'll have a wiki or you'll have a post-incident review or something that's going to answer some of these things for you. And we're in the Midwest, so I know it's super uncomfortable to ask people these kinds of questions, but it's really important to normalize it. Normalizing it for you normalizes it for other people, so it means everybody understands things better. You can ask in your one-on-ones with your managers. You can make it clear to them that your intention is just understanding, which will put a lot of stress off of the situation. If you're going to ask your peers, I really suggest that you don't ask about specific decisions, but you ask about entire projects and entire experiences that they went through around the decisions. Because what's often going to happen is you're asking somebody because you disliked a decision, and you're going to come off as an asshole every single time. Find your organizational historians. Every organization has them. These are people who are often longer tenured, but not always. But these are the people that happen to be able to answer every single question about a project that happened 5, 10 years ago. They can talk you through the lineage of each team, how it came together, what the team was beforehand, all that kind of stuff. And they can tell you the impact of every single acquisition that the company has ever made. These are the kinds of people who really love answering these questions for you, and you really need to utilize them. You do this kind of interrogation process enough, and you're going to start seeing patterns emerge. And these are the political bodies in your organization. And yes, you're going to see the obvious things. You're going to see the teams, the normal reporting structures that you would see on an org chart. But you're also going to start seeing things that you didn't expect. Maybe there's a group of people who all started around the same time 10, 15 years ago. They all still get lunch together. And because they've been around for a while, a lot of them have been promoted into higher roles. And because they're friends, they talk shop while they eat. And you might start seeing that all of their projects tend to get executive support. And all of the times that they want to hire a new person, they happen to get that headcount. And it's because they have multiple people higher up lobbying for them, because they're friends. Or maybe you find out that a third of your engineering org all used to work at a different company and have slowly been hired into different positions on different teams. And you happen to see that they all tend to vote as a block, because even when they're not actively communicating with each other on a thing, they've all experienced similar things at their previous organizations. So they all have similar backgrounds and they think similarly because of it. So when you've identified all of these different political bodies, you can again begin researching them and asking questions to understand them. Is this an official political body, like a team or a committee? When did it come into existence? What was its initial purpose? Did that purpose finish, and did they continue on happening anyways? Has membership changed in the past? Are there defined membership rules? Does this team and its manager have the same power as another team or manager that reports up through the same chain? Again, your goal is to learn how your organization is actually doing things. Your org chart is insufficient for understanding this because it really leaves so much contextual data on the floor. It might be an okay place to start, but it's never going to get you where you need to go. This contextual data is going to tell you how and where to socialize your ideas, how to get into the groups that you need to be in, and whether ideological differences are going to be blockers. So now we're going to spend some time on some common political structures you're going to find and how to work within them. We're all super familiar with hierarchical structures because most of our companies and our country operate on these models. We can easily represent them with org charts, which makes us feel like we can understand them. The basic idea is that you have power and authority based on your position in the hierarchy. In your average company, we'd say something like an IC reports to a manager, reports to a director, reports to a VP, to a CEO, and maybe there's a board or investors above them. And each rung up on that ladder has more power and authority than the last, and they can make decisions or force people below them to do things. And what you're going to find after careful analysis is that even though your org chart says people are equal, power and authority throughout hierarchy is very, very asymmetrical. To use a Star Wars example, nobody is going to complain when Darth Vader force chokes someone outside of his reporting chain because he has more authority as the Emperor's right hand and more power by virtue of being a space wizard. In an engineering org, this is going to look more like a dev team derailing an ops team roadmap by demanding new platform functionality for launch that needs to happen in 2 weeks. The primary challenge in navigating overly hierarchical organizations is that your ability to do so is often limited by the competency of your management chain. Good managers in hierarchical orgs do a few things that I want to touch on today because they're going to help you in the future. First, they grant authority to their reports. This gives their reports a seat at the table to show off their expertise and build trust and authority across the organization. And this, in the long run, will decrease reliance on their management chain needing to handle every small cross-org things that come up. Second, they encourage their reports to talk to people higher up in the management chain. You shouldn't be having one-on-ones with your skip levels or your directors or your execs every week, but they should be happening on some sort of regular schedule, and your manager should be making sure that they're happening. It's important for you to get that face time. And third, they don't act as a shit umbrella. They do make sure that feedback coming in for you from other parts of the org is constructive, though. Many managers try to protect their teams, and while that's noble in theory, it prevents their reports from repairing things when trust is broken across org boundaries. If your manager does not do these things for you and does not accept constructive feedback when you try to help them do these things for you, you do have a few options for navigating things. The least destructive thing you can do is to build trust and authority through non-hierarchical means. The easiest ways to do this are things like staying at the org longer and having more tenure. People trust people who've been around longer. You can build and show off domain expertise, which will make people trust your knowledge. You can also attempt to manage up, but if you do that for too long, you're probably going to burn out. And if you're bad at it, it's no better than the other major thing that you could do, which is going around your manager to your skip level to get things done. If you try to do that in an overly hierarchical org, that's going to cost you political capital. And it might end up in you eventually being terminated because you're being insubordinate. So let's talk about flat structures, or as I like to call them, liars' hierarchies. Now, a true flat org is great. Don't get me wrong. But in our late-stage capitalist society, unless your organization is actually built off of a co-op model, you have explicit hierarchy through ownership at a bare minimum. Additionally, if you don't have the right policies or more often the right people who are skilled at facilitating these types of org structures and who also know how to cede power and authority when it comes time to do so, you're going to start seeing implicit hierarchies begin to form through things like expertise, tenure, leadership, and that sometimes even morphs into explicit hierarchy. A wonderful example of these problems is the vast number of Web3 and crypto projects we saw over the last 2 years, where in theory they were co-ops. Everybody had the same amount of power because it was a DAO, but the founder of the project was still able to rug pull the whole thing and run off with all the money. This combined with the fact that people generally have less experience navigating flat organizations can make them really hard for people. So my advice to you is really start by figuring out whether your org structure is actually flat or whether people are lying to themselves. If so, great. Your next step is to start learning the new culture and the new norms that you haven't experienced before. Start learning how to give back your power and authority to the group because that's where it belongs. And if your org isn't actually flat and you want to stay at that org, you've got a few not so great options. You can try to facilitate the org into becoming flatter, which at some point is going to mean that you need to get people to give up power and authority. If they're not willing to do so, it's going to come down to how cemented that authority is and whether people are willing to continue to support it. You can also try to get people to see that the org isn't actually flat and make those org structures explicit, but that's often going to be an uphill battle, and even if you win that uphill battle, you're going to disillusion people who liked the veneer of equality. And if neither of those seems like great options to you, you're kind of left with accepting the situation as it is and helping other people navigate what you've figured out about your organization. Sorry. So committees. A lot of people don't like committees. So we have this tendency in tech to reinvent them, except we always leave out some of the important things that keep them useful. We give them fancier names like guilds or communities of practice. But I mean, if it looks like a duck and it quacks like a duck, I'm not an ornithologist up here, I'm a tech person. You probably have a duck on your hands. Here's the thing, people have been running and trying to figure out how to do committees better for millennia. Do you really think that your organization, without doing any research outside of maybe what a popular tech company did 10 years ago, you think you're going to be the one to get it right this time? If you've never come across a committee, it's a group of people from different parts of your org who come together to make decisions or do a thing. Like anything that's actually collaborative, it's expensive because tying up a bunch of people's time to do a single thing is expensive. The only thing that tends to be more expensive is when you needed a collaborative activity and you didn't do it, and now you have to redo the whole thing, but this time collaboratively. And again, there are a lot of resources and books out there on how to run committees well. The abridged version that we'll talk about today is that your committee needs a charter doc. Your first meeting should be working on this document and ratifying it. It needs to contain things like the purpose of the committee, whether it should automatically dissolve, how membership of the committee is formed, whether every member of it gets a vote and how voting happens. What's the meeting cadence? How are you communicating outside of the meetings? If you're in a very hierarchical organization, you probably also need to say who's sponsoring the committee because that's who gives the committee power and authority to do things. Your committee also likely needs a chairperson. The role of the chair is not to lead the committee, but to facilitate it. This means that they should not hold any power or authority that anybody else on the committee does not have. They facilitate things like the construction of the agenda, making sure an agenda is followed, creating additional meetings if needed, and making sure that no single person or party dominates conversation. Your committee needs a secretary. The role of the secretary is to produce minutes for your meetings, and minutes are not notes. Minutes should be a document that represents what took place at a meeting, what was decided, what were the viewpoints that were discussed, who voted on what. They need a lot more context. In a best case scenario, they're compiled from the notes that many people took. With the technology in the 21st century, sharing notes to make that happen isn't hard. These minutes should be sent to the committee with enough time for people to request changes if things are misrepresented before the next meeting. And your meetings need agendas. The first thing on every agenda should be ratifying the minutes of the previous meeting, followed immediately by allowing people to, because people miss meetings. If people want to try to overturn previous decisions that were made without new evidence or perspectives, the convener of the committee should shut them down immediately. That, you already discussed that, it's recorded in the minutes, move on. And every agenda needs to have a ballpark for how long you're going to discuss a thing, like big, medium, small, it even works, even if not minutes. Your agenda needs to be sent out far enough ahead of time for people to decide if I can just skip this meeting, or if I'm going to be on vacation, can I get somebody else to attend for me? You can just go out and read something like Robert's Rules of Orders. You can learn about consensus decision-making. It's not hard to figure out how to do these things better. But before you discard something from one of those things because it's too bureaucratic or onerous, actually figure out what the intended effect of that tool was and try to rework it in some way that's less onerous for your organization. So once you've identified and understand how your organization is working, here's a few tips I have for actually navigating things. You need to internalize that you are probably wrong, like about everything. In fact, here are some of the ways that you are wrong. And yeah, maybe you're technically correct, which is the best kind of correct, but at the same time, the ways that you're wrong have spilled onto this second slide. And the funny thing about working in the kind of systems that we work in is that we're often both right and wrong at the same time, and context happens to be king. So the first really easy thing you can be doing as you're engaged in collective decision making, especially when things are heated, is to make this complexity clear. Get everybody to take a step back and pay attention to the context that other people in the room have that they don't have, that you don't have. Remind people that we are here trying to figure out a path that feels best as a group, because each option that we're going to put forward is probably both right and wrong by some measure. There might be a better name for this. I've been using this for a couple years. Soft decisions. I prefer soft decisions. These are decisions that you can undo or overturn easily. You make the best decision you can up front, and if it's a code decision, we can do such easy things as test it in a non-prod environment, test it behind a feature flag. If it's organizational or architectural, we can do things like write it up and send it out through a process like an RFC or an ADR or what have you. You get feedback. If that's too onerous, you can even do something simple and write it up and send it in Slack, right? The point of soft decisions is that you're making an initial decision with a small group of people who you believe has the most context to answer a question or make a decision. But it still enables other people who are impacted by the decision to have feedback on the decision. It's the same reason that we do code reviews. But it's important you know that you should never, ever do this if you have no intention of accepting or acknowledging and incorporating the feedback that other people give you, because that's going to damage trust between you and the people giving feedback. Going even further than that, you can delegate your decisions. You can let people who are the most impacted by a decision have the final say. For example, if you're making changes to an API that's heavily used by another team, and you've got like 3 or 4 ways that you could make this change, but all of them are going to cause the other team to make some changes to their code, you can say, hey, here's your decision. Here's your 4 options, go. This needs a few things to be successful. First, supply them with the context around the decision and the expected impact. They need to understand why it's important to them. If you're an ops team and you're trying to get your dev team to make a decision around Kubernetes, they probably don't know why they care. Second, give them options that you are okay with, but more importantly, explicitly call out the options that you are not okay with, because they're going to brainstorm other options, and they might come up and want to do the thing, come up with and want to do the thing that you really, really don't want to do. And third, you've got to accept their decision, even if you would want to do things differently on your own. There's about one really great replacement for authority when it comes to navigating organizational politics, and that's trust. There are a lot of good resources out there for how to build trust, so I just want to touch on 2 quick things. People are often looking for shortcuts on building trust, but it turns out that helping your colleagues, executing on your day-to-day tasks, and just really making sure that the needs of your team, your people, your organization are met always remains your best option. If you're sick of hearing people say, chop wood, carry water, we could try it out differently. We could say, carry water, chop wood. There's just no replacements for this. Now, the next thing is that at some point you're really going to fuck up. You're going to do something that damages trust or frustrates your colleagues, and you're going to need to figure out how to fix this. In America, we say, yeah, just apologize. Except we all know that apologies are usually just bullshit. So in Jewish culture, we actually have this thing called teshuvah. It's a whole process around making amends for your transgressions. You see, your apologies need to come after you've owned the harm you've caused, after you've committed to changing your behavior in the future, after you've worked to repair any of the damage that you have done. Only then can you apologize and have the other person not consider it bullshit. And even then, you still have to prove in the future that you're not going to do the same thing every time that comes up. But if you do all of that, you're actually going to restore trust in the way that a simple apology won't. I'd like to leave you with one last big tip, which is to study anarchy. And a lot of people laugh at this, but a lot of the basic ideas and concepts in this talk come from having read anarchist literature. Most of us have spent our lives not really understanding what anarchy actually means. And the central idea in anarchist philosophy is just that it's wrong for people to have authority derived from hierarchical structures. People should have equal power. That's the core concept. That's it. And when you do that, or when you believe that, trust becomes a lot more important than authority. And that means that anarchist orgs have a highly democratic nature, and they tend to build very strong tools for collective decision-making because they have to. So as an example, I've linked here a talk from DevOps Days Minneapolis 2016, and it's about how the Occupy movement conducted meetings with hundreds, thousands of people that had never met each other before. If you don't believe efforts like that could be successful, it's a good time to point out that the whole push for student loan forgiveness over the last few years originated in Occupy Wall Street. So it can be effective, very effective. So the thing that a lot of you probably didn't want me to talk about today, but I'm going to do it anyways. People like to make this really complicated, but it's not. I'm going to make it easy for you. I can't work with someone who wants me dead because I'm Jewish. Trans people can't work with people who want them dead because they're trans. Women cannot work with people who think that they are inferior engineers just because of their gender. The paradox of tolerance does not come with an exception for people who only spew intolerant bullshit out of the workplace. In the same way that a black person cannot stop being black at work, a racist does not magically stop being racist at work. This isn't hard. Now, I'm sure that there are going to be people in the audience who are still on the fence and want a business case. Every time someone deals with something like racism at work, we have to dedicate a portion of our brain power to figuring out how we keep ourselves safe from our coworkers. That brain power is better spent, and we want to spend it working on the work for the company, the organization that we are there to work for. So, literally keeping racist, sexist, and homophobes in your company actively makes your other employees perform worse, if it doesn't outright push them out of your organization. And the people that leave are going to talk. And that's going to mean that you're going to get fewer qualified candidates in your pipeline to interview in the future. Do you really think that you can make do with just cis-het white men? That's not going to work long-term for you. They're also just bad decision makers. Do you really think that someone who believes that women can't engineer as men can tell you adequately whether a team that's hopefully 50% women, whether that team has the capacity to do something like implement Kubernetes? They're probably going to be undervaluing half of the team. We have countless examples of companies who don't test their products on people of varying skin colors, which ends up with those products not working on large swaths of the world, which means that you can't sell it to half the world. And do you really think that anybody who in the year of 2023 still believes that Jews, take the blood of kids to make our food? You really think that that person doesn't have other dumb beliefs that they're holding on to for no reason? Maybe about technologies, maybe pushing you to technologies you shouldn't even use? This isn't hard. You just kick these people out of your organizations. They make your organizations worse. So that's all I have for you today, and if I didn't scare you off, I'm currently unemployed and looking for a new management position. So if you're hiring managers in the next few months, please, we should chat.
Oh, that was great. And apologies to the junior engineers out there that still believed in meritocracy.
That was a journey that got us there.
Yeah.
All right. Well, we've got excuse me. We got one more set of sponsors before we head to lunch, and I've seen the menu. It looks pretty good. So not that it's not been good the whole time. So our first sponsor is Mesmo. Am I saying that right, Bill? Sure. All right, cool. Just checking.
Yeah, I'm Bill Meyer. I'm from Mesmo. Show of hands, I haven't seen the audience yet. How many developers? Who's all? Okay, a few. How many of you are SREs? How many of you are SREs that had to try to interpret other developers' logs? It can be painful. It can be a challenge. And so Mesmo is an organization that's in an emerging space on providing telemetry pipelines. And telemetry pipelines can operate on your telemetry in real time, metrics, events, logs, and traces. We can help you get better insights out of that telemetry stream to help make your job understanding your services and your applications and how they're performing much easier So come and check us out. We're right down this hall on your right-hand side, and we'll tell you all about it. Thanks.
Fantastic. Next up, we have GitLab.
Hello, Dave O'Neill from GitLab. Thanks for having us as part of the event. We're enjoying our opportunity to be part of the community here. 3 things that I want you to take away from this. Number 1, we are GitLab, we are not GitHub. There's a difference, right? And it's half the people we talk to at our table, 10 minutes into the conversation, they were, oh, you're not GitHub. So 1, we're GitLab, not GitHub. 2, DevSecOps is hard, right? Communities like this are put together to make it less hard. Our approach is we bring the tools that are available to the DevSecOps practitioners together in a platform to help make DevSecOps less hard. It would be a folly of me to say to make it easy. But the platform approach makes things less hard for the work that we do every day. And the third thing is AI has a role, right? AI has a role in making things less hard. Come by our table and let's talk about the role that AI can play in making our jobs less hard. So again, thank you for letting us be part of the community.
Thank you so much. And next, Roost AI. So I think we're not sure where they are, so I am going to give a shout out to Roost AI. I have heard that they can save you at least $100,000 a minute in your DevOpsing. So you should all go give them money. I know, awesome. But if you haven't stopped by their booth and gone to see them, but we appreciate Roost for being a sponsor of Chicago. And if you are listening, Roost AI, later we can sneak you up here, probably do something. Cool. Next we have Spot by NetApp.
Thank you. Yeah, appreciate being here. So my name is Phil Trowbridge. I'm an account executive here. I handle sales for Spot here for our Midwest organizations and customers. We are all about cloud compute optimization. So everything we do with our customers is all about driving down the cost of compute in your public cloud infrastructure. Doing that with a number of different methods and a number of different tools, but our goal is to make sure that you are always using the most cost-effective per unit cost of compute, leveraging more cost-effective reserved instances, being less reliant on savings plans, and leveraging Spot more predominantly in your infrastructure by giving you an SLA and de-risking the most risky part of leveraging Spot. So yeah, stop by our booth, come talk to some of our folks, and we'd love to talk to you about how we can drive cost savings in your infrastructure and drive down the cost of compute, automate your environment, and get you back to building and shipping code and applications.
And our final sponsor of the day is Relativity.
Hello, my name is Lauren. I am a senior recruiter with Relativity, so I'm here in a little bit of a different capacity than folks trying to sell their software. I'm just trying to offer up maybe a new opportunity for folks. So we are Relativity. We build a platform that helps our customers structure unstructured data and information for their investigation and internal investigation needs. So we have over 300,000 users worldwide in over 40 different countries. We are headquartered here in Chicago, but we are remote as well all over the globe. We do have a booth over here if you'd like to go ahead and have a chat with us. We have some fun things to give away. But yeah, thanks so much.
Awesome. Are you maybe hiring engineering managers? We might know somebody.
I was thinking the same thing. I feel like the shade has been like a metaphor.
It is.
Right?
There's something going on.
Yeah, Josh was over here dropping truth, and then the shades just came up, like shedding the light.
Right, or to reflect the shade he was throwing at some things. So with that, we will get ready to head ourselves to lunch. We will be back here at 1 o'clock for our Ignite talks. Enjoy your lunch. Go give the sponsors a little bit of a hello, and such, and we will see you back here in about an hour. Okay. All right. Welcome back from lunch. Hope it was enjoyable. I thought it was pretty darn good.
Lunch
pretty
was good,
tasty.
yeah.
Pretty tasty. We are going into our tail end of the program. And before we go into Ignites, which is a super awesome part of DevOps Days, we do have a little special something we are doing. One of our organizers here, who's been helping out with DevOps Days Chicago for quite some time, turns out today is his birthday. So Albert, come on up here. Woo! Thought it would be fun if we could just all together, those of you who still have a voice after karaoke last night, we just sing happy birthday to Albert and watch him blow out a candle and stuff. So 1 and 2 and happy birthday to you. Happy birthday to you. Happy birthday, dear Albert. Happy birthday to you. I have a small confession to make. So we thought we were going to be really slick and surprise Albert. And I was texting, we have a text thread with the venue, and I was like, can we arrange this? Can we do whatever? And a point, and then Brian says, you know Albert's on that text thread. So we tried, but thank you, Albert. Happy birthday. Thank you for everything you do for us. Albert is a very usually not invisible, but behind the scenes, does so much for this event, and we're so happy he's part of it. Thank you. And with that, we can move on to our next part, which is the Ignites. Just as a refresher, for Ignites are a specific style of talk. It has some constraints. With constraints comes freedom. And that is, it is 20 slides at auto advance every 15 seconds. Tell us one idea, and there you go. And so we're going to go one right after the other. We're going to start with our first speaker, who is Kadesha.
Hello, I'm Kadesha. I am a developer advocate at GitHub, and today I would love to talk to you about how to write a technical blog. So, how many of you have ever written a blog post or a technical article online? Okay, quite a few. I'm very impressed. So today, hopefully I can encourage the rest of you to start sharing your knowledge online, because whether you believe it or not, you have a lot to share, and we all want to learn from you. So, like I said, I'm Kadesha. I work at GitHub as a developer advocate, and I love creating technical content, especially video content, and I'm severely addicted to TikTok, and surprisingly, I find writing very challenging, but one of the main reasons to write a technical blog is because it allows you to give yourself more exposure and attract opportunities to you. So because I started sharing content online, I was able to leverage those content to get a job at GitHub. So what makes a good blog post? You need a clear title that's easy to understand. You need to have a clear target audience or a person that you're talking to. And you definitely need to have a CTA at the end of your article. So components of a blog post include a cover photo, a title, an introduction, the body or the meat of the matter, a conclusion, and your CTA. Then you can include stuff like code snippets, pictures, examples, links to external things, and when it comes to your cover photo, you want to make sure that it's attention-grabbing and it relates directly to your article. For example, I have this here that says, Learning Ruby on Rails. I wonder what the blog post is about, right? It's obviously going to be about Ruby on Rails and how you can get started learning the content. Your title needs to be clear and concise and speak directly to your target audience. Ruby for Beginners, your complete study and installation guide. Using words like you and your allows you to connect directly with your audience, and that way when you get to your introduction and you're starting to share your own experience, your audience member actually knows, okay, this is what it's going to be about based on the cover, and then the title, and here's the introduction. The body is where you really get into breaking down the content that you want to share. Break down your blog post into different sections, because that's going to make it a lot easier for you to share your technical thought processes to the world. When it comes to the body, you want to pretend like you're talking to one person. This will help you to break down concepts and to not use words that are like containers and DevOps and Docker, because what does that mean to somebody who knows nothing about it, right? When writing your body, you want to write as if the person doesn't know what you're talking about. So if you're going to say Docker, make sure you link to an external article that they can, read up about Docker, or say, hey, Docker is XYZ. So explain everything in your blog post, essentially. And if you're including code snippets, please, please, please make sure that we can simply copy it and paste it into a code editor if we want to run it. It's so annoying when I go to copy a code and it's a photo. Please don't do that. Please don't do that. And your conclusion is essentially wrapping up the entire article, and at the end you want to present a CTA or a call to action. What do you want your reader to do once they're finished reading, right? So an example CTA can be, follow me on Instagram, follow me on Twitter, try this project out for yourself and tag me so I know that you've tried it. Go to my repo and star the repository. Those are some examples of CTA. So explain everything in your technical blog and pretend no one knows the tech that you're talking about. Nobody knows what you're talking about, so explain everything. If you feel like you're not explaining it enough, you probably aren't. So when it comes to writing your own blog posts, there are 6 things I like to think about. I like to think about the idea, the research phase, the planning phase, the writing phase, the editing phase, and of course, the posting phase. So in these different phases, you will need to do different things. So keep track of your ideas in like a notepad or a notebook. I like to just pop up my phone and put it in a note quickly so I don't have to remember it. I can just have it there later. When it comes to research, Google and YouTube are your best friends. Oop, this had like a whole thing on it. It's okay. Google and YouTube are your best friends when it comes to research. Go to dev.to, go to Hashnode, go to HackerNoon. Look at what people are searching up. Go to GitHub and look at the repositories and the questions that people are asking in issues. So once you have the research done, it's time to start writing your outline. And this is an example of what a blog outline looks like. I have this in the GitHub gist, and I'll share it on Twitter after this. So you want to make sure that you break down each individual concept. So thank you. Scan this QR code really fast if you want the slides, and I look forward to reading your blog posts.
Should I just start? Hi, my name is Sugar Overflow. Also, my name is Fatima. I'm a developer evangelist at GitLab, where I work on DevSecOps, AI, and community strategy. This is an ode to technical debt. It's a rant turned love letter to the chaos that was the year 2020. So 2020 was a really tough, grief year for me. I had just lost my father, I'd gotten started in DevRel, and suddenly I was like the only maintainer of my organization's several crucial but severely underutilized and undermaintained open source projects. So I just had to do everything myself. This ode is a tribute to some of those heartbreaking nights of burnout. Our story begins once upon a time in a land far, far away where lightning bolts strike. A legend now etched into this rhyme about a tool by which open sourcers conquered the night. Terminus build tools, ye old DevOps pipeline. And so arrived our adventurer at hand to maintain and build upon the tooling mentioned, and found there was a mountain of technical debt. No documentation, no roadmap, no updated issues, only dread. Composer 2.0 was on its way, so that meant that build tools too needed an update. So she gathered the council of open sourcers from the land, but no one had the pieces of this mysterious roadmap. And so to the king she went, asking for support, for resources, for contractors, for budget from the court. "Be gone," said the king, "and go do your magic. You don't need a whole team, just you will manage." And so our adventurer crawled through the depths of code, configured, refactored, tested, and steered, and with help from her peers, she persevered. Features, dependency updates, new releases, she built bridges to connect all the dots and pieces. And then came a wave of users, 5,000 and more. Issues opened, bugs reported, edge cases inshore. The High Council of Open Sourcers met each week and noted that it was too much for one person to upkeep. Our adventurer, she tried to communicate the debt, to request resources, to express the growing impact. But when the storm of issues and merge requests came, it was only her mentors and friends who kept her sane. In the quiet corners of the kingdom, she confided her fears and doubts to her friends, feelings of incompetence and dying hope, of overwhelming stress over this tool that the company didn't officially support. They reminded her that it did not reflect on her competence and her self-worth, that the weight of this mountain that she carried alone was a testament to how much she'd grown. Enough is enough, she realized one day when she couldn't come up with enough reasons to stay. And in the meadows, she met a delightful tanuki. "Come with me," it said, "to a land far away, where we'll value your expertise and you'll have a meaningful say." In this new realm, she found these tanukis, their meetings documented, their promises a reality. Processes and notes weren't just artifacts on shelves. They were living documents, part of their team ops delve. And they held each other accountable, she could tell. In this new realm was governed by a king who was thoughtful and wise and relied on his advisors for their insightful advice. A court that sought every tanuki's success. So the success of one was collective progress. And in this new realm, no tanuki was left alone to struggle on an island of debt, isolated and unknown. Our adventurer, she found in her team support respect for her knowledge, unlike before. With them, she found her strength restored. She thought back to the realm that she had fled, where all the open sourcers navigated their individual dreads. But here among tanukis, there was unity and vision, weathering storms together with clarity and precision. Transparency and results was all in the mission. If only she knew the void she left behind, a troubled king unconfined. In haste, he recruited open sourcers 7. When she was there, he never lessened her burden. But when she left, he realized the magnitude of her leaven. So from the crossroads of burnout and strife, our adventurer chose a different life. To you, I pass her legend, her tale of resilience. To all those laboring under burdens of stone, that sometimes moving on is a stronger defiance than carrying a mountain of tech debt alone. Sometimes moving on is realizing that you shouldn't set yourself on fire to keep an organization warm. Tech debt can be really overwhelming, and sometimes we have to realize when it's time to step back and maybe chase a new beginning, like the one that brought me here. Thank you so much.
That was awesome. Yes, I'm John Willis, and this is how not to do a 2-hour presentation in 5 minutes. Maddie asked me to do this last week, and I was lazy, and I just took a 2-hour presentation. So we'll begin here. I am John Willis. I am Botchkaloop. And this was a 10-year journey for me. I fell in love with a guy named Dr. Deming. Most people know me. I've been obsessed by him. I am also known as John Willis and Botchkaloop. And it's about my book that came out Tuesday. So it was pretty awesome to finally get this done after 10 years. Actually, as of this morning, it actually showed up as the #1 in some category, hottest seller. But it's in Kindle and it's in audio right now. There's actually a supply chain shortage on printer books, so that'll be in January. If you don't know me, I've written about, this was my 12th book. And that's actually a code to get a discount. The IT Revolution folk has discounted it. But I wrote the DevOps Handbook. I wrote Beyond the Phoenix Project, Investments Unlimited, and have worked for way too many companies. If you don't know Deming, you probably do know him. There's a lot of quotes, mostly. I think there's a rule that if you write a Deming DevOps presentation, you have to have a Deming quote, but I don't know. I haven't seen one this week. But learning is not compulsory, neither is survival. My favorite one is basically every system is basically what you get. If you don't know him, he's basically 70-year career of incredible stuff, from mathematical physics to epistemology, statistics, psychology, a system thinker, industrials. And by the way, even though he died quite a while ago, he's a DevOpsist. There's 3 things you need to know about this person. He invented a thing called analytical statistics. His 14 points is what he's most known for. If you Google it, you'll see it. And probably lesser known is this profound knowledge idea, which basically he created. And so the analytical statistics is interesting. It's the difference between information and knowledge. If you look on the left, basically knowledge is like a histogram. Statistical analysis is basically understanding trends and patterns. And so his 14 points, I can't go through them all here, but purpose, having a purpose, an aim, basically leadership, production. But the biggest thing, he was a humanist. He cared about the condition of work for humans. It was really profound. This is the most important part of what he has, and this is the core of my book. It's basically a way to understand complexity, and it deals with knowledge. How do we know what we know? How do we understand what we know? How are people motivated? And system thinking. And my whole book's about this. So I took a lot of stories. The last third of the book is really modern, with Deming in the cyber world. I mean, he died in 1993, so he never got to experience it. But if you haven't heard about the Knight Capital incident, it was $440 million lost in 45 minutes. The company went out of business in 24 hours because of missed comma in a deployment. And so I took the profound knowledge from the SEC cease and desist, and I applied that lens of knowledge, variation, psychology. So missing things. If you read the cease and desist, it is basically no deployment, no test coverage. And then I just spend, I go through all 14 points with all modern examples. I don't know how any on the East Coast 2 winters ago, you couldn't get cream cheese. It was a ransomware. It was a company that didn't really understand security. So I tell a really sort of funny story, a lot of funny stories in the thing. Stop improving. This is Shannon Leitz. If you don't know Shannon Leitz, Google her now. She's amazing on security. She talks about adversary analysis. So I used her way she thinks about solving problems through knowledge. If Deming was alive right now, he'd be really pissed about the way we do incident management. You know, John Osbar says, you know, incidents are unplanned investments, right? You know, if the way we do P1s and P2s, I mean, I spend a lot of time thinking about that and talking about that. This is, I cover the Equifax breach, the Struts too, for those of you who have been around for a little bit. Like, I talk about how Conway's Law played a real significant way, the way they took them 6 months to figure out how to solve the problem of losing $5 billion market cap in like a day. And then Deming hated MBOs. He basically said that he cared about like how you do things, not what you do, right? And so like what was the method that caused you to do that? And by the way, folks, hold on your chest, he would have hated OKRs for the same reason. I mean, he would despise them. Again, he hated slogans. He hated words that created slogans. He hated, you know, zero defects. I mean, he was about something called operational definitions. And so in general, he didn't come up with management by means, but basically the simplest answer is give a person, give a person a fish and you feed it for a day and you teach them how to fish, they feed for a lifetime. And like that's management by means, right? But here's the good news. I'm telling you, I know this man, he would have loved SRE. And because basically it's a decoupled way of thinking. Like things like OKRs and MBOs, this is hard to do in 5 minutes. But like the way he applied his system thinking and knowledge. Anyway, that's it. That is a code to get the discount. And if you have any questions, I'll be around. So.
Hey, friends. How's it going? Yeah. All right. I am Jason Yee, because thus I'm on stage. If you don't know me, let's chat later and you can meet me. But DevOps is dead. Or at least that's what someone told me. Platforms are what you need, they said. And the more they tried to explain it to me, the more it sounded like this. The relationship between dev and ops should mirror the relationship between ops and AWS. Yeah, that's pretty messed up. So it kind of makes sense why for at least some people DevOps is dead. Yeah, not great. But there's a lot of organizations that have platform teams and they're successfully doing DevOps. And so that got me thinking, well, if you can do it, like, how can modern platform teams, how can they really fail at DevOps just to make sure that it's dead? You know, how can you take like cloud native principles and just really screw them up? You know, adapt modern practices to keep your organization stuck in the past. I found the solution for this. And the solution is microsilos. You need microsilos for your microservices. Now we all know that DevOps isn't just dev and ops, right? DevOps is everyone. It's everyone in this room. It's everyone in your organization. And microsilos are a really effective way to ensure that one service team doesn't collaborate or talk to another service team, or that they don't talk to QA teams, or security teams, or business folks, or even platform teams. Now, this all sounds like, yeah, it's kind of easy, right? But we all know that you can't just take your existing app and lift and shift it to get it into the cloud. That's not cloud native. And you can't take your existing silos and lift them and shrink them to get microsilos. So I want to give you 3 tips to create good, effective, cloud-native microsilos. And the first is, don't use RFCs. Now I know a lot of you are thinking, great, I'm safe. I'm not using RFCs already. Don't kid yourself. RFCs are really sneaky. RFCs, or requests for comments, are a way to share your engineering plans with the broader organization. They're fantastic if you want to get new perspectives or foster collaboration. But, you know, you want to avoid that, right? Because we're creating microsilos. So the problem with this, though, is if you have microservices, you're probably going to do something silly, like creating a Git repo for each service so you can work on the code. That, unfortunately, leads you to adopting open source software practices. Things like creating issues and pull requests, which means that those other teams are going to start to comment on your issues, or worse, they're going to create their own pull requests. And it's a slippery slope from doing that to starting to adopt practices like RFCs. Now, the second thing that you need to do is not use service catalogs. Don't use service catalogs, it's just bad. But inevitably, what's going to happen with all those microservices is that some nosy busybody is going to want a way to see all of the services in your org, even though your service is none of their damn business. Now, if you're actively antagonistic towards other teams, you're a jerk. But if you don't know about them, then ignorance is bliss. You can't collaborate with teams you don't know about. This used to be really easy in the old days, because service catalogs were manual. You had to get people together, get that information, and manually document it. The problem is we've advanced technology. And so now you have all these platforms that'll go out and auto-discover your services, pull the info, build the catalog. I've heard a certain robotic dog will actually pull metrics automatically without instrumenting it, and you have this great service catalog. But that leads to my next point. Number 3, do not ever use shared observability tools. Someone once said, and I think I might have heard this from John, but someone once said that if you can't measure it, you can't improve it. Well, if that's true, someone probably said that. I think I heard from John, but I think Abe Lincoln probably said it, because it's on the internet. But that underscores the problem, right? You have things like the internet. If you have ways to verify data and get accurate information, it's going to lead people to wanting to improve things. That's not good for microsilos. So, how to fail at DevOps the cloud native way. Number 1, create microsilos. To do that, do not use RFCs. Just maybe don't even use GitHub, right? If you don't use GitHub, people can't collaborate. Don't use service catalogs, because service catalogs, if you don't know about other teams, then it's much easier to not collaborate. And definitely don't use those shared observability tools. When you measure things, people want to improve them, and you definitely don't want that. Or maybe you do. So if you do actually want to do these things, let's talk some more in open spaces about how you can adopt these tools and other best practices to do DevOps the cloud native way. Thanks.
Hi there. How y'all doing? Good. We're going to make some paper airplanes. My name is Laura Santa Maria, and I am a developer advocate at Dell. And I'm going to awkwardly try to do this while I'm giving a talk, so we're going to see how I do. So making paper airplanes is pretty easy, right? You take some paper, you do some basic folds, creasing, and bam, look, you got a paper airplane. But it's not quite that simple. A lot of time goes into the design and the aerodynamics to get distance, aerobatics, all that fun stuff. DevOps is deceptively easy too. You put some pipelines together, give people fancy titles, make some dashboards, right? And then, bam, you've got DevOps. But what happens when you have an outage, or horror of horrors, you have to actually talk to someone? So, it's all the same. For paper airplanes, we have common basic folding techniques. For DevOps, communication skills, the ability to, share and collaborate and do all the things. Once you know about the basics, you need to put in the time to master them. So that means if you don't have sharp folds or good communication skills, you can't fix anything. You can't make anything fly. You also need to know your materials. So get to know the people, get to know the paperweight. Once you've mastered these basic techniques and gotten to know everyone, you can make your very, very first one. So the classics are the best way to start. A basic Dart, or get everybody in the same room and start to work together. Once you're ready to actually design, though, that's when things get fun, because every mechanism for flight is actually different. And I'm going to try to fold this while I'm talking. So this is the fun part, as all the darts start to fall down. But with DevOps, hey, balance is everything for when we actually try to do all of this. Balancing people, processes, and tools is extremely important for DevOps, because if you spend too much time trying to balance your plane or balance out with all of your processes, you'll forget to actually get to the rest of DevOps. So, now, it's all too easy to go down the dreaded rabbit hole, because I'll be honest with you, no one ever actually takes a ruler to make a paper airplane. If you do, I love you. But that being said, the dreaded rabbit hole for DevOps is also the same. When we think about optimizing, though, remember, there are always some trade-offs. So, you can't have everything in one design or one organization. Maybe you want aerodynamics. Maybe you want something kind of fun that looks like it's impossible to fly. Technique is important, though, when we get into all of this. The way I fold a plane and the way I throw it to make it fly is actually, it kind of matters. But DevOps, community of practices need collaboration and everything, but there's no one true way to get there. There's actually no true way to fly to make a paper airplane that actually kind of flies. Maybe. Possibly. Who knows? So, when it comes to processes, though, accuracy is critical. You need, to be able to actually get this accurate. I'm going to try to throw this. We're going to see. This one's an over-the-head kind of thing that's supposed to actually fly. So, it's okay. Now, with that accuracy, you need to keep your creases sharp, so that the sharper the crease, the better it's going to fly. I'm not going to try to fly this one, because this one's my last one. But with those sharp creases, you need to also keep your skills sharp in DevOps to continue moving that through your organization. And I finally caught up to my slides. Now remember, every flight is a test flight. Your first or your 50th flight, no, that's actually a real person, by the way. Your first or your 50th flight could fail. But every time you do DevOps, it's going to change, right? So when you fail, you need to explore why. You need to understand why that paper airplane failed. As I step on my paper airplanes. If you've ever actually crashed the nose on something, you need to find out why that happened. If you fail with a production incident, you need to start going through and understanding. With that being said, there's no need to blame anybody, because what's that going to do? Well, I'm not really going to get anything off the ground that if, I made this wrong and I try to blame somebody else for it, what's going to happen? I don't get another plane out in the air. So sometimes, though, you can't reuse. You have to rebuild it because maybe the nose gets all messed up. When it comes to people, don't be afraid to go try something new, because the process that you tried might not actually work. But in general, remember why you got into this, what the passion is, why you're deciding to go out and do this DevOps thing, or whether you're trying to not get paged at 2 a.m., or you're trying to get a message across the room, which maybe is how I know so much about paper airplanes. But don't take yourself too seriously. If you do that, you kind of alienate some people. You might get into too many arguments with them. Maybe you try to make more micro silos, I don't know. But that's kind of important. So in general, the joy of flight, or the freedom from that 2 a.m. page, is all that matters. Thank you for letting me make some paper airplanes live on stage by accident.
Other mic? Oh.
All right, let's, if we could have our Ignite speakers just stand up real quick where you are. Let's just have another round of applause for Kadesha, Fatima, John, Jason, and Laura. What a great way to get our afternoon going. So, now it's time to engage in some self-serving things as audience. The reason you're here, I know, yes, we're here for open spaces and to learn and blah, blah, blah. I know you're here to win some stuff. So, we are going to start our sponsor giveaway. Sponsors, as you're lined up, if you maybe bring the line down this way so you don't have so far to go. What's going to happen is we'll bring the sponsors up one at a time. They'll announce who their winner is. So if it's you, awesome, cool, come on up, and they'll connect with you over on that side, and then we'll be able to get a picture, all that fun stuff. Sponsors, when you come up here, say your company's name so we can put your slide up on the thing. See how that goes? So you can actually feel free to bring the line all the way up to here, so you don't even have to go so far. I'm saving you some time, although I know some people like to do the stroll. So I guess we'll start number one. We have Acorn. I'm guessing from the shirt. Yeah, I can hold this for you if you like.
Hi, everyone. Yes, Tim from Acorn Labs.
Okay. Your hands seem full, so I thought I'd help you.
John Bonget from ROI.
Jean Bonget from ROI, are you here? Awesome. Come on up. Excellent. And it was that Nintendo Switch? Excellent. Okay, next up.
Cloud Bees.
Okay, what do we got? What, here.
We have a waterproof JBL Bluetooth speaker, so if you like singing in the shower, this is going to give you a little bit of help if you can't carry a tune. Our winner, Kevin Bard, Morningstar.
Kevin Bard from excellent, awesome, congratulations.
So, yeah. So from Sleuth, the engineering efficiency platform, we're giving away 3 $100 Amazon gift cards. I don't have them with me, but we will email them, no worries. The 3 winners are Mayara Govea from Skip the Dishes, Parthiban Siva Kumar from US Bank, and Ian Robertson from Hyatt.
Congratulations. Next up, platinum sponsor, Site 24/7. What do you got?
So we have Bose noise cancelling headphones. So we would have collected this cards, right? So we're just going to call out the number.
So wait, everybody make sure you got your card. We'll give them a second. You got your cards? Okay.
So it's 5341.
5341. We out here? 5341. Going up. Okay.
5346.
Wait. 5346. All right. Woo. And you go over there, and then we'll get a picture for you. Thank you. Next up. I know you. Nikki and I used to work together a long time ago. Not that long ago. We're not that old.
We're not old. I'm from Mesmo, formerly known as LogGNA, and we had the very rare, apparently can't get it anymore, Lego set of the Chicago architecture. Our first pick was Menage Coupon.
From Medline?
Yeah.
All right, come on, excellent. That is hard to get. I wanted to get that as the speaker gift, and then I found out how much it cost to get it on the secondary market, and you got books instead. So.
Hi. Oh, Noble 9.
Noble 9.
This is also Legos, but NES and apparently Mario moves. And the winner is Marcelo Costa from Fetch Reward.
Excellent. And I think you're going to ship it to that, right? You have the, yeah, so just relish it. But if you're up here and you want to get your picture, please find, okay, is that you? Are you Marcelo? Okay, I found you. All right. Next up, we have Tail Scale.
All right. If I can hold it, that's even better because I don't have to give it back. So as it turns out, you are all winners of my favorite thing. You get a tail net, and you get a tail net, and you get a tail net. It's under your chair. It's not under your chair. It's actually at tailscale.com. Smash that blue button. But what you're really looking for is the Steam Deck. Oh. By accepting this device, you solemnly swear to put Tailscale on it and do dope shit. Rick Oswowski. Yes. Should we do a second one?
You have two?
All right, yeah, it's like a Mary Poppins bag. There's no bottom. Dexter Horthy.
Hey.
Woo! Thank you.
Also, we appreciate a good Oprah reference at DevOps Days Chicago. So, all right, next is temporal.
Thank you. I'm Matt with Temporal. How's everybody doing? We picked 3. There's only one winner, though.
No.
Oh, sorry. There's only one winner. Ben Wolkoff.
Ben. Oh, it's your call.
Well, if he's here, he gets it.
Okay.
Yeah. All right. Good job, Ben.
All right, next up is Puppet. Puppet.
All right, I borrowed a couple of dice from our friends over here at New Relic. They're pretty light up and everything, and drew them right here in line. So we've got 3 to give away. Shyam Jain. Am I pronouncing that right? All right. And Milliam Alves. And Susmitha Maripala.
Do we get those other 2? There's one more. Who was the second one?
Milliam Alves.
William here? Oh, maybe you got to roll again.
Sharon Jackson? Oh.
Sharon Jackson. There we go. All right. Excellent. Observe. Didn't recognize your logo. I'm sorry. Wrong side. Okay, Jerry.
Should have worn it backwards. All right, so you guys may have remembered, but we have an option in our giveaway. You can either win free beer for a year. Yes, that's true. Shipped to your house. Or a PS5 if you're not into beer. So the winner is Navin Rai from HCSC. And I'm sure everybody wants to know what he's going to pick, right? You don't have to decide today, but I think the crowd is interested.
Okay. If you have input, I'm sure he'd love to hear it. Maybe have an open space about which prize you should pick. All right. Next up is Launch Darkly. Here, I will hold this, and I'll give you that.
Hello, I'm here from Launch Darkly. We have some Bose noise canceling headphones. And the winner is going to be Mandar Konder from Discover Financial.
Excellent. All right. App Dynamics.
Hey there. Our winner today for the Apple AirPod Pro is Iago Santos from Nubank.
There we go.
All right.
I am proud of you all for being here. Everyone has mostly been here. This is amazing. Okay. All right, Rick, I'll hold for you. All right. This is Transition Technologies.
That's right. 1 second here. And we have 2 games here from Snap Circuits for you to build. One is like Lego, and the other one is electrical of some kind. Less like Lego. Our first winner is Jonathan Juleson.
There's Jonathan.
There we go. Great. And our second winner is Shreyas Rain.
Excellent. Well, there you get your photo. Okay. Trend Micro.
So somebody got really lucky and just won back-to-back gifts from Discover Financial. Shreyad Rain wins this lovely Legos Mandalorian Star Wars head.
I'll go chase him down. All right. Hi.
Postman.
Postman.
Hey, I have a limited edition bobblehead and assorted swag. 3 winners listed in descending order of pick. Lucas Fox.
Lucas Fox. All right.
Sumit Agarwal.
Okay.
Oh. Yasmin Reyes.
Yasmin? Someone's pointing. Oh, is that also? It's a different person, though, right? We'll let the booth work for one person. I'm saying you can't get picked twice for that, but okay. Excellent. All right. Cosley. Yeah.
All right. I'm going to need everybody's help here to pick the winner. So I need a number between 2 and I heard 7 already. Okay. Wow. That was quick. So 7 is, oh, and by the way, what are you winning? This is a customized Ascend keyboard. Exactly. Up to a $400 value. You meet with me, and we'll go customize it for you. Yeah, it's inflation these days. All right, so number 7, Vervin Kerr, W-Y-V-E-R-N, Vern Kerr. Did I pronounce that correctly? Ah, Wyvern. Apologies. Thank you very much.
All right. Sumo Logic. Here, I will hold the mic for you. That seems easier.
Hey, thanks everybody for stopping by our booth. We have a home theater and a backpack. So our winner is Kevin Bard from Morningstar.
Kevin. All right. And New Relic. Oh, here. Best for last. Jeff Smith, did you enter this one? Jeff is the dice. Did you enter for this? Real quick. The winner is Jeff Smith. All right, these are the super cool light up dice. Did you make sure you get the ones back from Puppet? They didn't walk off with them? Okay, yeah, Ben, we're watching you. All right, what do we got?
All right, so hi, I'm Sade C. Johnson. Our team decided to do things a little differently, so if you did not enter yet, you still have an opportunity to do so. It's still a bit early. You could get the dice just by showing us that you instrumented the platform, the Dangerous Dave game, to the New Relic platform. Just show us the dashboard and you can get some light up dice. Our friends, sponsor friends, are able to get some now. Don't forget to return it. And then for those who actually want the grand prize, which is a limited edition backpack along with the $100 Amazon gift card, the current high score is 4,500. So if you beat that and you beat the next one and the next one and you get the highest score, you can get those prizes. So you still have some time. So come to our booth. Thank you.
Awesome. We did bring the card. I see I just put them here. Okay, so now we have the drawings for the sponsor passport stuff. I think the way we're going to do this, so let's put the prizes all out. So as we draw a name, so you pick what you want, right? When you win, you come up, and we'll tell you what everything is. And everybody that wins, just give them a yak. You also, you will also, so we have, for your choices here, we have a Nintendo Switch, we have the Starry Nights Lego set, we have a mechanical keyboard, we have a yak Squishmallow. We have, how much are the cards? $100, $50 Amazon gift cards, and Chris Reed will give you the other $50. And then we have 5 copies of Operations Anti-Patterns DevOps Solutions signed by the author. Jeff Smith, did you sign these? You already signed them.
A little special note in each of them.
Oh, okay, gotcha. Which means you already know who won, so you know what note to write. And there is some sort of modern Game Boy thing. So, handheld gaming something or other. So, with that, I love the fact that I said Nikki and I aren't that old, and we're both putting on our reading glasses. So, read that as you will. Okay, and again, must be present to win. And I'm going to say, if you're working the booth, too bad, because you should be in here. So, ooh, okay. Our first winner is Tom Wojciechowicz. Wojciechowicz? Does Tom know who I'm talking? Okay, Tom, come on up.
It's a solid attempt.
I'm sure you're picking the Game Boy thing over the Switch, right? Also, you have to take a yak. So what do you take? What are you picking? This one? Oh, geez. So that's a rough choice. Okay. Excellent. Okay. Go get your picture.
I would just love to have a photo.
Yeah. Okay. Our next winner is Floor Dress. What are you picking, Floor? Starry Night. Floor. Just throw a yak at her. Okay. Our next winner is Audra Burkus. Andre. Why do we only have one of the books? I thought we had 5. Okay. Okay, well, we'll figure it out. We'll go slow so the other books can get up here. Someone in a red shirt, go find 4 more books. All right. Next is Julius Bautista from Innova. All right, you got the Squishmallow, you got the Amazon gift cards, a copy of Jeff's book, or a Game Boy thing. Okay, go ahead and take that one. Excellent. Okay, next up we have Haruya Oraya from SciComp. Haruya Oraya? Over there? Oh, okay. Was it? Or wait. Oh, there we go. Okay. Oh, hey. Yeah. It was slow. I was close. I missed slightly. Okay, so we also do have more copies. Okay, you're like, it's fine. I'm going to take this. Sorry, Jeff. It's a $50 gift card. Next up, I did request to write this so I could read it. Dean La something. L-E, where there's a B in there.
Dean over there.
Did we find? Okay. Okay. Oh, we got the books. Okay, good deal. Yeah. Oh, if you're, that's the Game Boy thing. That's an Amazon gift card. There's a book. Okay. I'm not gonna. No, this is a first name that is barely legible. So. Okay, here, if there's more than one of you with this name, y'all can fight over it. I believe it says Eduardo. Okay. Throw a yak at him. Well, that's fair. That is understandable. Okay, gift card, Squishmallow book. All right. Next up, we have Jacob Levin. Jacob, all right. Craig Gehrig. Craig, all right. So we have, after Craig, we have 3 more. Craig is behind you. 3 more for the last recipients of the Operations Anti-Patterns book signed by author Jeff Smith. Anna Carla Cal. Oh, Anna. Anna Carla. She's a DevOps Days organizer from Brazil. And we have 2 more winners. Iago Nobre, another DevOps Days organizer. This is not rigged. The reason you know it's not rigged is there's a card in here that says Henry Stratton, which is my son. So I haven't pulled that one out. All right, we have one more winner. And it is Pinky Satiku. Pinky. All right. Thank you to all of everybody who participated. We do still have plenty of yaks if you'd like to adopt one and bring it home to your children or yourself or absolutely. And also, again, don't forget as well, we have the COVID tests to take on your way out and such. But it is time, I believe, to move on to open spaces. Yes? Yes. All right. Kev, you're going to have to advance. Oh, you have the... I don't have a clicky. We don't have slides? Oh, we need the slide with the... Okay, we're going to talk for a minute while we're getting going. This is cool. Also, someone in a red shirt, at some point, someone needs to have ownership of updating the spreadsheet. So let's just make that happen. Okay. This was, by the way, the whole updating the open spaces spreadsheet was a great example of like when everyone owns it, nobody does, and we all just assume someone else was doing it. So we're going to fix that. I don't know if we even have slides
I don't
yet.
think we have slides.
That's okay. All right, that said, we don't need, okay, there we go. Perfect. Awesome. So we're going to do things tiny bit different today. First of all, we're not going to, go through the process. If you were, how many people, I have a question though before we get started. How many people yesterday was your first time ever doing open spaces? Keep your hands up if you're really excited to do that again right now. Awesome. Great. That's what we want to see. So what we are going to do is if you have a suggestion for your topic for an open space you'd like to discuss, you come up here, you can write that topic down, and then we'll read it and say, hey, we'll say how many people are interested in talking about Kubernetes in space. and then we'll put it up there and we'll figure it out. One of the things we have added on to, because not everybody is going to want to necessarily come up and read. And even though I said before, I said, hey, well, come and write it and hand it to me. Well, that's kind of rough too. So if you go, so this QR code and that bit.ly link take you to the spreadsheet for topics, but there is also a link in there for a Google form. So go ahead, put your topic ID in there if you would like. And Dex, I've decided, is the one who's going to do this, is going to be watching that form responses, which probably means we need to give him access to the form. Kevin, maybe you can, or Kevin, do you have, okay. We'll take and then write them on a Post-it, and one of us will read them and go along there. So that said, we're handing these out, and as you're ready, if you get topic, come line up by Jeff. And the other thing is write your topic, and when you come up, please read it succinctly, like just in the one or two sentences, because that way we'll be able to. And if it can't be explained in the one or two sentences, then we'll make it shorter. So the who's it? Oh, the markers. Oh, they're being passed around. Who's got the pens? Yeah, go ahead.
Who wants to have a conversation around empowering our peers to facilitate psychological safety?
Empowering your peers to, oh, wow. Jeez. See, I'm not old. My voice cracked. All right, that looks like medium, probably. All right.
Hey, there's a number of us who do this at a bunch of different DevOps days, but we're going to get in a room. We're going to anonymously share salary data and have discussions around our salary data. We can do some calculations on it as well. So it's a in real life talk pay session. We've done this because it helps people get raises. It helps people know that they're being undervalued or that they're doing really well for their area. So come talk salaries with us.
For talk pay. Okay, and we will, you all know that we do that, by the way, that's done in a specific room. There's specific rules to keep it private and anonymous, so, okay.
Hey everyone, a little bit less funny than a Magnite, but cloud native DevOps best practices.
Best practices for cloud native DevOps. Medium. Medium. If we don't know, medium. All right, I think that was medium. All right, JJ.
I actually have two. Yeah, I don't think you're on the line. One is first, Reddit is dead, so where do we find our communities now? Oh, you were? Oh, yeah. All right.
Okay,
cool.
so where do we, non-Reddit solutions of community, okay, medium.
And then my second one is, if you run like a GitHub organization or an NPM organization or PyPy organization and namespaces, how do you manage those? Because I have problems.
Managing namespaces and such things, small. I'm gonna put a little bit of, if you can remember what we say it is when you walk it over there, and then you can make sure that they heard, if we say small, medium, large for yours. So, okay, come on.
Hello everyone, my name is Tarun. I'd like to talk about secret management, what you're doing today, what you would like to see doing, and what you see the future of it being in a cloud native world. HashiCorp, Vault, secret management, AWS, Key Vault, whatever. Anything else you've used.
Managing secrets. I think that looks like that's probably a large. Large, okay. Large. Excellent. Perfect.
So, Kubernetes changed our lives. Clouds changed our lives. What's the next thing will change operational things?
The future of operations, i.e. where should we invest? Okay, looks like a medium. Excellent.
Hey y'all, I'd love to talk about Nix and NixOS, where we're at and where we're going.
Nix and NixOS. Small, I think, but good. Okay.
Yeah, the topic is making tracing useful for ops. How do you make traces and the volume of traces coming in quickly respond and let ops know that things are bad in a particular business flow?
Making tracing better for ops. Small. Yep.
Hello, I would like to talk about software supply chain security because it's big and scary and very complicated, and I want to hear what you're doing, what you wish you were doing, and what tools you wish you had to help you.
Looks like a medium, I think. Okay, Lee.
Hi, friends. Lee Kapili. Hi, Maddie. I don't drink. Maybe there's other people here who don't drink. I organize an inclusive space called Sig Boba. It's just like people who like try to get in an intentional place where there's like actually on purpose no alcohol. There's lots of places and times and rituals and stuff that we hold culturally in our community that tend to be kind of exclusive or even marginalizing in ways that we don't realize. I want to hold a place, open space about Sig Boba and inclusive spaces in our whole community.
Excellent. How many? I think that's at least a medium. Okay. Don.
I've got one called Pipelines and Flexibility. So the idea is at one extreme of my delivery pipeline, I can have 10,000 permutations of a pipeline because everybody does something a little bit different. And on the other end, I can have everybody's upset that they can't do the one thing that they all really want to do because ops hasn't done it yet or ops hasn't automated yet. So how do we strike that healthy balance?
Pipelines and flexibility. At least a medium there. Frosty.
Hey, what's up, man? Hi, everybody. This is a open space that I used to propose at DevOpsDays a lot pre-pandemic, and somebody asked me yesterday why I didn't propose it. So I'm proposing it now. It's a little bit different. It's physical health. We talked about mental health yesterday. Physical health is also important, especially if we're working from home, although that's becoming less and less of a thing. Seriously, what sort of exercises and things can we do over the course of the day so that our bodies don't fall apart when we're hunched over a keyboard? If you're interested in that, I have a whole routine I can show you. It's great for beginners.
Looks like large.
All right, great. Thanks.
Thank you. My name is Rich. Meetings. We have too many meetings. We have way too many meetings. How do we get our work done? How can we make meetings more efficient and maybe less of them?
All right. Making meetings better or not having them. Okay, medium, I think.
We'll have a meeting.
We'll have a meeting about it. It's going to be great.
Hi, I'm Maddie. No, David.
That was yesterday's post.
Yeah, I know, but I'm old. Okay, I want to talk about micro versions of Kubernetes, tiny distributions that you might want to run at the edge, and all that fun stuff.
Tiny itsy bitsy Kates. It looks like a tiny itsy bitsy space. Probably a small. Not tiny itsy bitsy. I just had to make a joke. It looks like small. What's up, Kev?
I've got some submissions here from the forum. The first one says testing, which could be an actual topic or me testing the forum. I should have probably been more clear. But the first real one is managing internal politics as a remote employee.
Oh, managing internal politics as a remote employee. That looks pretty medium to big. Big. Who's writing them?
Oh, yeah, I guess I should probably write these on some Post-its or something.
Well, okay.
I'll do one more, and then I'll sneak back in the line somewhere with some Post-its. We'll do Terraform project structure and state management.
Okay, that looks pretty big. Pretty big. Okay. Shane?
Hi, my name is Shane. Yeah, okay, that's loud enough. I'd like to hold a topic on neurospicy coping mechanisms. What do you do to help you stay productive and get through the day?
Show of hands for that one. Looks looks like a medium. Excellent. Mike?
Hi. We hear a lot about how we can't do what we want because leadership gets in the way and leaders don't let us do things and it's all leadership's fault. So I'm going to do a session on how do you talk to your executives, work with your executives and your leadership team. Turns out I'm one of those people.
How many? Looks like small, medium. Okay.
Hello. Thinking about multi-cloud engineering support group and discussions around avoiding vendor lock-in.
Show of hands for that. Small. Okay.
Hello, I'm Jeremy, and I'd like to talk about self-hosting open infrastructure to defeat big tech and government surveillance.
Okay. Self-hosting for reasons. Okay. It looks like small.
Hey y'all, I'm Chris. I am pitching LLM/data platform engineering, which can be just a broader conversation about platform engineering, but it is stuff I'm working on. So.
Okay. Platform engineering with some possible specifics. Raise your hands higher so I can see. Okay, there you go. Yeah, I think it looks like small, medium. Okay.
I thought maybe a few people here have some smart home stuff. So if you do like Home Assistant, you have like Lutron switches and Philips Hue lights and kind of almost sort of have them working and want to talk about it. I also want to talk about the shit that doesn't work.
Troubleshoot Paul's house.
True.
Yeah,
True,
looks like
true.
medium to large. Okay.
I'd like to talk about cloud monitoring solutions, native versus the observability platforms, cost for small apps versus big apps.
Show of hands for that one. Looks like a medium, I think. Excellent. Okay, Richard.
Okay, I think I might be feeding off of his, but I wrote down, I wanted to talk about more about like what we're doing in our DevOps practices at home and how we're beginning to automate our home more using DevOps principles and practices.
Okay, maybe we'll combo that. Maybe it'll be separate. We'll see what happens. Troubleshoot Paul's home DevOps.
All right, I'm back, and this
Okay,
time
back with Post-its.
Post-its. The next one I think is perfect for the task I have at hand, which is an introvert's safe space, tools for inclusion of introverts.
Okay. Excellent. That looks like medium to large. Oh,
still got a pipeline of Post-its here.
Yeah.
The next one we have is migrating engineers to a new platform.
Migrating engineers to a new platform. Looks like medium to large.
How to automate production readiness checks and seamlessly and continuously recertify services to avoid atrocities in prod and improve on-call life, which I've written down as production readiness check.
Production looks like probably a medium for that. Yep.
Let me scroll back over. Local development, testing, linting, tooling, and best practices.
So an actual testing one, not the testing one.
I may have inspired someone.
Local development testing. Looks like, what do you think, Jeff? Well, maybe you figure it out.
Continuous documentation. I think both a continuation and restart of yesterday's conversation.
Okay, continuous documentation, continuously. Medium.
The last one I have is networking. People, not computers.
Networking of the people variety. All right, that looks like a large, I think.
I'm just going to refresh. I think that's it.
I think we're good. Okay, so looking at the schedule, the first open space starts at 2:15, which is in about 10 minutes, so we will self-organize. We will update that link quickly. So make sure you have that link bookmarked. And again, if you would like to be involved in the structured chaos of organizing the open spaces, the reason this may be relevant to your interests is things like, there's this one I want to go to and not this other one. But also happening and during our first space here at 2:14 is, wow, man, I feel like I'm 14 again. Is Eddie Knight will be doing a workshop on to the left. All your security shifted to the left, and that will be taking place in here.
And then closing remarks.
And we will be doing closing remarks at 4:45. So please come back here at 4:45 and enjoy. Thanks.
All right, we're going to have our workshop starting here in just a moment. But we have a special request from our presenter. They want to enter as dramatically as possible. So can I get everybody in the room to do a drum roll, please, as Eddie approaches the stage? All right, let's hear for Eddie.
All right, I will never make a joke again with you. That will not happen. So I do have slides, and I am not doing them correctly because I can see them and you guys can't. So that is how we're starting off our demo today. This is going to be a workshop. I want you guys to know that I will be attempting to speak to you. So if you guys could help, yes, thank you. I'm like stalling. That is how you use a computer. Oh, wow. So many problems solved all at once. So today we are going to be talking about shifting security left. This is secure software development. Why are we talking about app dev in a DevOps conference? That's a huge, great question. I don't know. It got on the agenda, so we're going to be talking about it. We're going to be talking about moving security into our SDLC, every part of our SDLC. And now we got it. There you go. That's the title. And those are words about the title underneath it. For the hands-on portion of this workshop, we're going to be going into GitHub and Sonatype's Nexus tool for like 5 minutes. We're going to be hopping in there. The GitHub portion you guys can do on your phone. We're just going to be looking at some code, maybe leaving some comments, some GitHub issues, that sort of thing. So if you do not want to participate and you just want to listen and watch me do it up here on the screen, I want you guys to not move. If you think you might participate, and you might be dropping some GitHub issues in here to kind of like be a little bit more interactive, raise your hand. If you think you might be participating at some point during this. Okay, I will not count it. You're my new best friend. All right, so I'm gonna try to win you guys over as we go along. We didn't screen mirror here. So I've got one last obstacle to cross before, oh my gosh, you guys, this is cool. It's like down there also. So I guess I could rely on that if I was more clever, but I'm not. So I'm going to try and screen mirror this. Ooh, I can't actually read my menu from down here. Somebody's taken over for me, thank you. Yep, figure out how to screen mirror so that way I can do the displays, thank you. You have eagle eyes, you can actually read that. Oh, gorgeous. Got it, thank you so much. All right, so a little bit of back story on this. This workshop was designed to be a 2-hour workshop that could be extended or condensed. So we're going to try and condense it into, we've got 39 minutes left here and one closed tab already. So we are on good track here. The perk you guys have from me is that I have to be on a flight at 5:20. So I'm going to be booking out of here after this. So there's zero chance of me running over with this presentation. My name is Eddie Knight. I do a lot of work for my company Sonatype. I do a lot of work on the different open source foundations. So you can see here in my Google Drive that I've got some OpenSSF scorecard work that's been happening. What is the name of our presentation that just got closed out while we failed to security? How did that even happen? I'm going to stop talking. I think I'm actually distracting myself from getting this up here. All right. So my day job is, well, my number one job is raising a very, very small child right now. I like to think that we're doing a reasonably good job. My wife is way better because she doesn't have ADHD, and she actually pays attention to the child when he needs things. So he is very fortunate to have a great mom. I am the open source program office manager for Sonatype, so that gets me in a lot of different conversations with the Linux Foundation, a lot of different organizations that are within there, such as FinOS, the Open Source Security Foundation, CNCF, which you guys are probably most familiar with. This next KubeCon, we're actually going to be doing the Cloud Native Security Slam, so it's a really big event that we're hosting and making happen, so that's really exciting. And I just released a book, which my baby is holding in that picture. You can get a hold of me in some of these places. Normally, I would be hanging out afterward, but as I mentioned, I don't have a flight, or I do have a flight, so I don't have time after here. So if you guys have questions, let's make sure to use them during this slot of time. This presentation is going to be walking through the entire SDLC. We are going to be working together to make security improvements at the dev stage while we're securing our dependencies, while we're doing our infrastructure as code. We're going to talk about that, and we're going to look at our CI/CD, and then we're going to triage anything that we found. You can keep track of where we are in the presentation on the right side of the panel. When we talk about shift left, there's a lot of different people who throw this around. So when I'm talking to you guys and I say shift left, I'm talking about getting things closer to that left side of the infinity symbol that we always throw around. That does not mean that there isn't a lot of other ways to practice security. We're just not going to talk about a lot of the other awesome ways to do it. In fact, in October, November for the CNCF, we're going to be doing all of these things. It's going to be really exciting, but today we are not focused on that. We're going to be looking at the SDLC. There's 3 different bullet points that I put on here for different things that we need to. The bulk of this is just plan to do secure software development. Make sure that your teams have time. Make sure that you have the right skills, that you've equipped your teams, and given them the tools that they need to actually do secure development, not just development. There is a mantra on the blue section right here. I'm going to be repeating this throughout all of it. If you remember nothing else, the mantra is 3 different points that we're going to touch on that enable us to build for secure software development. And then briefly, we're going to touch on testing for secure software development through ASTs. But there's a lot more. So when I said to the left, all your security in the box to the left, there is definitely some left out. Thank you, Meme, for pointing that out. Through our conversations, we're going to get into the application code on the teal slides. On the green slides, we're going to look at application dependencies, touch briefly on secure composition analysis, SCA tools, and during the yellow section, we're going to discuss securing infrastructure as code, and we're going to get hands-on again with the orange section, which is CI/CD, and we're going to close out with threat triaging. All of this, oh, yeah, actually I was really happy with this visual. The point is that when we're doing all of this, as we're writing our code, our secure code is going to go through our secure CI pipeline with our secured application dependencies to build our application. We're going to have our secure infrastructure as code with our secure dependencies that are going to go into our cloud infrastructure. There you go. I explained the visual. But as I mentioned, this is a 2-hour workshop. The last time I did this was a 4-hour workshop. We were very hands-on. 3 questions that you should be asking yourself as you are writing code. Any feature that you have, any workflow that you have, anything that you are doing during the SDLC, you should be asking these 3 questions. First one is, does this touch the internet? Does this feature touch the internet? Does this tool touch the internet? Does this process that I'm going through right now involve the internet? A lot of different examples of things that touch the internet. The most obvious one that all of us can think of is user input. When people can give things to us over the internet, that untrusted input is going to need to be handled well. But there's a lot of different ways. When things touch the internet, we need to ensure end-to-end security from wherever that information is coming from to where it is being consumed. Second question that we're going to be repeating throughout the rest of this presentation is, Does it take untrusted input? Obviously, our forms from users are always taking untrusted input. Less obviously, but according to the OWASP top 10, calls to a shared database should be treated as untrusted. So if we have two applications that are both putting information into a database and then consuming information back out of that database, that should be treated as untrusted because one application is not always in control of the data. So that should be treated as untrusted input when it's coming back out. Cookies, obviously. API responses, if you're calling out to another API, not only is it touching the internet, but it's giving you input back that is dictating how your application runs. You cannot necessarily trust that that will always be properly formed, and you can't trust that it won't occasionally be malicious. If we have a feature or process or workflow or anything that happens that takes untrusted input, we have to validate its integrity before we use it. The third thing that we're going to be repeating throughout the rest of these colorful slides is, does it handle sensitive data? I don't need to elaborate on this more. Sensitive data is sensitive. We need to pay special care to encryption, handling, and storage. The data in transit, the data in flight, we need to pay special care to encrypting it at every stage. So, right there, if you want to walk out and go to an open spaces, you have got this entire workshop right there. But we're going to go through together and look at how do we apply this into software development. Sorry, did everybody saw somebody taking a picture? You good? Okay, cool. So when we're doing this in software development, I spun up a repository specifically for this, so that way we can look at a very weak application. So if you want to type into GitHub, if you've got the GitHub app, you can pull it up. I'm going to click on this link on my repository to open it up. And yes, this is Sonatype Nexus Community, Code to Cloud Workshop. What I'm about to do is I'm going to open up that repo, and I'm going to start looking for a couple weaknesses, so that way we can make a GitHub issue for this. At the end, when we get to that red section, we're going to want to triage some of these things to figure out what was the most important. And we're going to look at different ways that we can triage the weaknesses that we found. So we need to at least have something in there to take a look at. So let's crack this open. And I'm going to cheat because I started late with my not knowing how to work my damn computer. I'm going to cheat, and I'm going to go look at previous different issues that people have discussed, different weaknesses on here that people have discussed, and I'm going to see if I can find a better way to articulate it, so that way the maintainers of this repository will finally freaking get to it. Because clearly the fact that it hasn't been dealt with means that somebody hasn't understood it, hasn't wanted to get to it, hasn't believed in the importance of it. So actually this one's pretty well written. This is a really good example of how we would like to see an issue tracked. Somebody went into the code base, they looked at it, and they saw a Java class in our code base that is using a insecure encoder, is what it's saying. And so they've given us details on that. Why is this insecure? They've looked at it and they've said that, hey, you're not actually encrypting things. You're not doing your encryption in a good way. And so they have given us, in this case they didn't give us any proof of concept on here, but they did give us the impact. And so this is a really good example of, if you are wanting to help your team or help another team, help an open source repository, this is how you should be communicating to them. You should be coming in and actually giving the details. If we were in a 2 to 4 hour workshop, we'd spend a lot more time practicing this and just trying to make these issues ourselves. But does anybody want to make an issue right now? This is where I get yelled at for making it too dependent on user input, user participation too much in a workshop. Oh my gosh. All right, so. Yeah. Do you want to walk me through making an issue? We'll use this as the prompt, but let's make a better issue. Let's make an issue that the maintainers will actually understand and listen to. So in this case, let's comment on it. Let's comment on this issue.
So the first thing I would do is we probably go to the documentation.
Okay.
Points to and kind of validates that this is for testing purposes.
Okay. So let's, yeah, no, I hear you. So this person obviously has some information that they didn't link to. So the maintainers can't tell, is this actually a problem or is this just you complaining, right? So let's find Spring Framework, paste that thing in there. Spring security without password encoding, plain text password. So here we go. We've got an entire blog article on why this is an issue and why it shouldn't be used. Does that fit with your idea? Correct. All right. Cool.
The other thing I would do is probably link to the source code where this is being used.
All right, so let's crack back up here, and we'll just do a quick search through this code base and find out where is this actually happening. So we've got two places that this is happening. So to follow your suggestion, and remind me your name? Tarun? Tarun. Tarun, thank you. So Tarun is recommending that we actually just find the places where this code is being used. GitHub's really helpful. If I just paste in the link, it turns it into a properly formatted link for me. And so we will grab this and just leave a note here saying, here's the places All right, so we have now.
So the other thing I would
Yeah,
recommend
please do.
is that you would tell them what would you use instead, or some sort of.
Yes.
Hey, this is what I would suggest based on my experience, or this is what industry standard practice is for Java applications to use.
Yep.
To perform this task.
Yep.
Or solicit from the community.
So, okay, so Tarun's point here is that if we want to improve this issue, what we should be doing is linking to why it's a problem, link to where it is actually a problem, and then either provide a proposed solution or reach out to somebody who could help us find the right solution. So that'd be the next step here, the next action item. So we've kind of commented on it, added that information, and the next step would be we either dig in and actually find a proposed solution or reach out to somebody to find it.
Right. So then, if they don't have a CI pipeline that does some linting or vulnerability scanning, you would probably want to create another issue to recommend they add that. That would catch this issue in a feature branch or bug fix branch or something before it made it into the production.
Oh, yes. Yep. And we're going to get to that in a minute, talking about how do we actually prevent some of these things from being introduced. But that's a huge point, is why was this allowed to get into the code base in the first place? In this case, it's because it's WebGoat. WebGoat is a resource that a current colleague of mine created with OWASP like 20 years ago. It's the weakest possible web application you could possibly find on the internet. So a new slide would be awesome. All right, so the next place that we see, so as we're writing our code, we could be creating vulnerabilities, but we can also be consuming vulnerabilities. And this has been a huge hot topic for the last 2 years especially, since the White House decided, hey, we're gonna open up that as a policy issue now, which is actually really helpful. So when we're bringing in our dependencies, if there is a vulnerability or a weakness in any of those dependencies, we now have that vulnerability or weakness. The average application has between 60 and 200 dependencies to build that application. If you have more than 10% of your project that was written by your developers, you are abnormal. It is normal to have 95% of your application was written by someone else and consumed as open source dependencies. So we need to make sure that we are not consuming weaknesses. Now, inside of our code base, what we did was we went ahead and set up a brand new workflow that we can now run on any pull requests that are not documentation changes. If we're actually changing any code, then we are now going to be running, and clearly we have not implemented the changes yet. We've just turned on the scan. I ran it about an hour ago, I think. We are running a set of dependency checks from Sonatype. We've got a web UI that we can go to over here. And actually, the username and password was in that CI pipeline. Super secure password, right? So what's happening is that when this CI pipeline runs, it is reaching out and it's telling Sonatype's software composition analysis tools to take a look at this repository at this time. And so we can see what the results of that check were by popping over. And if we wanted to upgrade this a little bit more, we would actually create some blocks, say we are not going to be accepting any pull requests that have any vulnerabilities, and setting up artifacts to actually like log it out and show that. So we have this as one option, and I'm going to come back to this in just a second. The alternative to setting it up in the CI like this for GitHub, if you're using GitHub, is Dependabot. So we have Dependabot on here also. And what we can see is that for the purpose of helping us secure our dependencies, Dependabot will actually automatically generate recommendations that we can look at and we can decide whether we want to consume these or not. Now, something to keep in mind, I'm going to, instead of pointing you to read a research report, I'm going to tell you one interesting fact from it. Last year's State of the Supply Chain report by Sonatype, it's widely recognized and quoted by everybody, but there's one interesting bit in there, which is that the most secure projects are actually not living on the edge and always staying with the latest upgrade, but actually staying an average of 2.7 versions behind. So staying a little bit behind the edge is going to require your teams to actually make informed decisions about when to do your upgrades and updates. And the result is that statistically your project will be safer. Now, living on the edge is safer than not doing updates at all. So Dependabot is great for that. It's going to get you that 90% improvement. But there is a 10% improvement by not simply bumping to latest every time, but by doing informed researched updates. That is where you're going to get your optimal results. Dependabot is where you should start for day one security improvements. If your project is not securing dependencies and paying attention to your update patterns, start with Dependabot or an equivalent for the platform that you guys are deploying on. But we're going to pop over and look at a tool that can give us a little bit more visibility into the resources that we're consuming. So in here, actually, let me go back up to the top so I can drill in. What I've found is that if we look at the report for our particular project, so this code to cloud project right here, I can click on this report and it already looks great. We've got 46 critical vulnerabilities, 42 severe vulnerabilities, 3 moderate. So this is just super secure. And we look at these and it's marked as critical. The score in here that Sonatype's giving it is a 10, which seems great. A 9. These are high, 7 is medium, and then there's some suggestions in here. So if you are doing quality enforcement on your teams, you could come in here and put some suggestions on like, hey, this is what we would recommend. And that's something that your security teams can customize in your policies for that. But we're not looking at that. We just want to do secure development where we are not introducing new weaknesses and vulnerabilities. So what we're going to want to do is create some issues out of this. We're seeing that there is code problems. There's currently issues in our code base because of our dependencies. So to get that information to be able to track that work, I'm going to actually drill in and use this tool, how it was designed, to look at, okay, what is it violating? Get some knowledge about this, and for each one of these, it is going to require a little bit of reading. We're going to need to dig in a little bit, and one way we can see is that there's actually a human written explanation here for us telling us exactly why this thing is there, why this vulnerability or weakness is introduced and why it's a problem. And then we can see what part of that dependency is actually causing the problem. So we have two choices at this point. If for some reason we can't update this dependency or an update is not available, this type of tool will actually I think this particular tool is the only one that does this feature. So everything else is this type of tool. For this specific tool, we're actually getting a root cause. So if we wanted to go make an improvement to that software dependency, we could. We could go into that open source package and just make some changes. And so from here, we'll pop over and create an issue and just let them know. And for the sake of time, I'm not going to actually do that. Ooh, I was very, very wrong about the ability to condense this to 45 minutes. So at the end of that, identifying all those weaknesses, we would want to convert those into work tracking issues, and we will now have more things on our backlog, our security backlog, for secure software improvements. The next one I am 100% just going to talk about. Infrastructure as code is a place where we can introduce weaknesses. It is often overlooked as just simply like we need to get Kubernetes up, get it deployed. We'll do some basic common sense stuff, but our infrastructure as code has dependencies also. So that's the first thing. It has the largest surface area. So not only will we stand the chance of introducing vulnerabilities through whatever dependencies we have, but we may simply expose the wrong thing. This is kind of the common sense area. And defaults are the devil's in the details. So I did make slides for each of these because we're not doing it hands-on. We're just talking about this one for a second. So external dependencies. If you're using Ansible, you have Ansible roles. Not every single one of those Ansible roles comes with a security SLA. There's not necessarily going to be guarantees on every single Ansible role that you consume. That is somebody else's code that was written to assist you. You cannot guarantee. You need to be taking a look and making sure that you are consuming that well. CloudFormation, same thing. Terraform, same thing. Pulumi, same thing. As you're doing your infrastructure as code, you will, at points, expedite the process by using somebody else's code, and you have to be doing this responsibly. Defaults are the devil in the details. When we're writing Terraform, when we're writing Ansible, very, very, very frequently, we have the ability to configure our resources that we're spinning up and spitting out. What ports are open, what different policies are being enforced for that particular resource. All sorts of different examples that you could think of. The point is that a lot of times there are defaults, and they are insecure by default. This is very, very, very common. It is problematic. Slowly, the open source communities are shifting away from insecure by default to secure by default. But the benefit of insecure by default is that you can get it running. You can get day zero out the door faster. And so those providers that are creating this infrastructure as code for you have a very high motivation to do insecure by default, which means that you, the user, need to be looking at what they're defaulting. And when you change them and when you start adding values in, the second point is parameterize it only when you need to. So when I am making my platform that my app teams can consume and they can select what different resources they want to deploy, if I parameterize things that could be overlooked and could be put in wrong by my users on my platform, I'm leaving them open to insecure configurations. So if you're doing platform engineering especially, parameterize it only when it's necessary. And remember the mantra. Is this touching the internet? Yeah, like the entire process is touching the internet. Is the thing you're deploying touching the internet? Well, pay attention to the different configurations that it has. Is it going to be handling sensitive information? Databases that really need to be putting a close eye on those. So remember that mantra, which actually, I'm just going to skip back to it for fun. If your infrastructure touches the internet, you need to be ensuring end-to-end security from every single part of it, from the internet to the resource and back. If you're resource is taking untrusted input, validate the integrity of whatever is coming into it before it's being used. That's especially true for platform engineering when it comes to infrastructure as code, because you as the platform engineers do not necessarily trust that your app dev teams are going to know every single thing that they're doing, and you want to make sure that you're only exposing what is going to help them. And does it handle sensitive data? So you're going to configure your resources in your infrastructure according to those questions. Now, in our pipeline, got one slide for this. I'm going to pop over into our pipeline to actually look at it. There are 3 big things to look at. The pipeline permissions. This pipeline is on the internet. It is you using the internet to talk to a cloud runner. That cloud runner is then going to be touching the internet to get its dependencies. It's going to be probably using its own dependencies through GitHub Actions, things like that. It's going to be handling secrets. You're going to be giving your AWS or your Azure passwords to your pipeline to be able to interact with things. You need to be paying attention to how you are storing those secrets and who is able to see those. And your dependencies. I just mentioned this a second ago, but if you've got a container, right, that cloud runner is actually defined by a Docker file somewhere. So you need to make sure that you are using containers that have the correct configurations. If you're using GitHub Actions or other third-party steps in your library, you need to be paying attention to those and making sure that they are configured correctly and that you're pinning your dependencies correctly, which I haven't talked about yet. But so rolling this to both the green tab and the orange tab, when we're doing our dependencies, we don't want to just ad hoc be consuming them however we want. Pinning dependencies is something that you should probably read up on. But the idea of pinning dependencies is that you don't simply say, I want to use Webpack version 1.2.3, but instead, when you're ready to go to prod, you're going to go and you're going to say, okay, what is the SHA for that commit? And you're going to actually specify that. Every language, whether it's Python, Golang, they have ways of pinning dependencies. And once you're done just deving this thing out, you're going to want to pin that dependency. It's going to enable you to do better, easier collaboration with your teams, cross-platform development, and then it also protects you from mistakes and malice at the dependency level, because not all languages prevent overwriting of versions. So with our dependencies, both in our CI pipeline, our infrastructure as code, and our application, we want to make sure that we are pinning our dependencies. But that's a sidebar. That wasn't on the slide. What I'm going to do is pop back over to the code base and give examples of how we might how we might secure our CI inside of here. So a minute ago, we were doing a GitHub workflow for the IQ tests. And what we see on here is that this is just a bare minimum, simple, not very complex pipeline, right? We're using Ubuntu latest. That's a dependency. In order to secure that, just that line right there, line 20, we probably should be picking a version of Ubuntu and locking down that runner. When we're going into each of these steps, it says for GitHub Actions, you do an @v3. Usually that's like what's recommended in the docs for almost everything for how you're specifying which version of the GitHub Actions dependencies that you're pulling in. We don't need to do @v3. We could switch that to a SHA and actually say GitHub uses actions/checkout/a SHA, and now we will know that if there's ever any issues, we can track it back to a specific commit. And if issues are introduced to their v3, they will be introduced later than us. And so we're not going to be assuming any risk without knowingly selecting that. Same thing down here. The other big thing about this is that your CI should be specifying permissions for each job. Inside of GitHub, the way that we would do this is that we would say at the top level, we would say permissions read only. And then down here, when we need to be writing things, we give write access to the specific job that needs to do it at the time that it needs to do it. So if I was tracking this work to be able to do the correct research and let myself do it later on, or sharing it with an open source maintainer, I would pop up, create a GitHub issue, and let them know that IQtests-YAML is not specifying permissions for the job or steps. And that's something that we should be keeping an eye on. Bum, bum, bum. Secret handling. Obviously, in that one, somebody pointed out a minute ago that we just have a username and password in plain text here. Additionally to having it in plain text, there are a lot of other ways to mishandle secrets. CI, Jenkins, Circle CI, all of them have right and wrong ways to handle your secrets. So that way, if you're doing it correctly, when users are running their pipelines, they won't be able to read those secrets by printing them out. And so that's something we want to pay attention to, is whatever pipeline you're using, you are handling the secrets in the correct way for that pipeline. Inside of GitHub, you will actually add your secrets in the settings. And once you add your secrets in those settings, the CI will not be capable of printing out that value. If it sees that value anywhere, it will be replaced by stars. And there's about 50 other ways that seem good but aren't fully complete ways. So you want to do platform-specific ways of securing your secrets. And we touched the dependencies, and we touched permissions. So the last thing for us to talk about is threat triage. When we're looking at common weaknesses or common vulnerabilities, these are two separate things. Weaknesses are the types of behavior that are weak. Vulnerabilities are known issues that can be tracked to a line in code and should be remediated. But both common weaknesses and common vulnerabilities are given ratings that are that you can find by going to MITRE and any of the resources, which we're not going to right now. But the first point, when you're trying to decide what work to do first, just look at how are other experts rating this weakness or this vulnerability, and focus on the biggest ones first. That's not where we would stop when we're deciding which to tackle first, because as developers, we have limited skills and limited time. There are only so many people on our team, and we can only do so much. And so if we have something that comes in that's a breaking change, that's going to require substantially more work to be able to go back. It's like, oh, I changed to version 2, but now that function doesn't exist anymore, so I need to go back through my entire code base and make all these changes. So simply because it was the highest priority according to vulnerability, it may take way more time. So take this into consideration when you're triaging your backlog. If two things are equal, do the one that you can finish first. And then, does your team actually have the skills and resources to accomplish this? And so if you don't, like if you cannot do it today, don't not do other stuff. That's a big thing. Like, flag this, raise attention, solve this problem by telling somebody else about the problem, but don't just not work on other stuff simply because you don't currently have these resources. So if you've got a list of 10 things to fix, and they're mostly equal in vulnerability rating, and they're mostly the same complexity, but you would need an additional tool or somebody that knows a different programming language to solve this problem, don't just not do the number one item. Or don't, holy crap, I've butchered this thought. Don't stop the rest of the backlog in favor simply because you can't do the top most important one. That was the last point on here. And what I was hoping to do, had I judged time correctly, was actually go back and look at some of these issues and practice them. So you guys who didn't raise your hands at the beginning were the ones who correctly estimated the length of this presentation. So thank you for that. And I'm sorry that I didn't get you more involved. So that brings us to the end of this. What we have talked about today is all on the left side, those colorful slides, which I didn't always blow up to full screen for you guys because I'm a terrible, terrible person. But the most important thing, if you guys remember nothing else, is just remember that no matter what you're doing in your entire SDLC, whether you're developing the actual code, the dependencies, infrastructures code, doing the CI/CD, keep these three things in mind, and it will enable you to be substantially ahead of the pack on secure software development. And now, do we have time left for Q? We have 3 minutes for Q&A, and then I got to go catch a flight, actually.
Questions? Comments? Problems with your life?
Counseling session. Yeah, we got Maddie here. You guys want to take advantage of the counseling? It's cool. Well, I really appreciate it. Appreciate the involvement, and I guess that's it. Thanks, guys.
Thanks, Eddie. Corey's got something for you on the way out. So that, for those of you out there in internet land, that brings us to the end of our live stream for DevOps Days Chicago 2023. Thank you for tuning in. We hope you learned something. We hope you clicked like and subscribe or whatever influencers say on the internet.
Yep, retweet, subscribe.
Do all of those things. And we hope to see you online next year for DevOps Days Chicago again.
Do we have a slide for feedback? One more reminder? And
for the people on the internet?
Good point. Well, they might still have feedback. They're like, hey, guess what? I don't
address all feedback to @darkandnerdy on Twitter.
Yeah, I don't like Jeff's pants. No, but thanks for joining. Appreciate it. We'll see you next year.